Hello students, welcome to IMS GATE Academy. I hope you are enjoying the sessions on Gate Booster. We have completed the Gate Booster and now we are into the quick revision through formulas. Good evening everyone. See, in this session, I would like to promise you that I will cover each and every formulas of each chapter and I will elaborate the concepts wherever it is required. So quick revision is actually in geotechnical. Myself is Sandeep Adari. I have done my BTech from JN to Hyderabad and MTech from NITK Surathkal with AIR rank 192 with All India Gate rank 192. I have an experience of 10 years in the field of gate coaching and I have been handled almost more than 30,000 students for geotechnical engineering. So geotechnical is divided into two parts. One is the soil mechanics part and other one is the geotechnical part. So, one is the soil mechanics and other one is the foundation engineering. In this session, I will quickly go through the soil mechanics part. So, my dear students, if you really like this session, please like the session and share this session. So, coming to the first topic I am going to discuss here is the properties of soil topic. The first chapter, and you can expect a question from this topic. From this chapter, my dear students, you can expect a question definitely from this chapter. So, before going to properties of soil, actually how the soil is represented. See, my dear students, if we consider a soil particles, if we consider these are the soil particles, the voids are completely, voids can be filled with air or the voids can be filled with water. So here, my dear students, if you see the diagram here, how the soil has been represented, you can say this portion is the, whatever the portion here we can say it as volume of voids and this portion is known as volume of solids. My dear students, what do you mean by volume of voids? Voids can be air. Good evening everyone. What can be the voids? Voids can be air or it can be water. So here, my dear students, I represents the air and water and solids. So soil particles will assume as solids. So here the complete volume is taken as V. So here, my dear students, before understanding the properties of soil, you should understand the basics. So here from this diagram, total volume can be written as volume of voids plus volume of solids. Now, my dear students, what are the voids we have? Voids, what we are having is, one is air and other one is water. So voids can be written as volume of air plus volume of water plus volume of solids. So this is a famous question in IES also, my dear student. How the soil can be represented? The soil, here how many constituents are there? One is air, another one is water, another one is solids. So soil can be represented as three-phase system. How does the soil can be represented, my dear students? Soil can be represented as three-phase system. Now, my dear students, if the voids are filled with water, then it is called fully saturated system. If the voids are completely filled with water, that soil is said to be fully saturated system. So, my dear students, in fully saturated, what will be the volume of air? Volume of air will be equal to 0 and volume of voids will be equal to volume of water. Similarly, if I take an example of fully dry soil, here voids are completely filled with what? Voids are completely filled with air. So here in this case, volume of water will be 0. So here, if you write the total volume is written as volume of water plus volume of solids. So my dear students, how many constituents are there here? There are 2 constituents. So good evening everyone. So what is the final outcome of this slide is, there is a famous question is, how does the soil represent? Soil can be represented as a 3-phase system or a 2-phase system. When do you say that a soil is 3-phase system? In case of partially saturated soils, you can say, my dear students, in case of partially saturated soils, a soil which is having both voids, where voids are filled with both air and water, then we call it as partially saturated soil. And when do you say that a soil is 2-phase system? Where a soil is said to be in 2-phase system when the voids are filled with air or completely filled with water, that is fully saturated system or fully dry system, we call the soil in 2-phase system. So my dear students, please write down the point. Soil can be represented as 3-phase system as well as 2-phase system. Now my dear students, we have the first formula here. What do you mean by void ratio? What do you mean by void ratio? Or why do you want to study about the void ratio? My dear students, void ratio is defined as the ratio of volume of voids to the volume of solids. It is defined as the ratio of volume of voids to the volume of solids. Now, my dear students, this is the famous question for all the competitive exams. What is the range of void ratio? This is a famous question. See, my dear students, what do you mean by range? If you say the range of natural numbers, what is the range of natural numbers, my dear students? It can be 1 to infinity. Similarly, what is the range of whole numbers? It is 0 to infinity. Now, my dear students, I would like to ask you one important thing. What is the range of void ratio? When you take a soil, practically, it is impossible to have a soil without voids. If you take some soil, there will be some water or there will be some air. You cannot expect a soil without 0 voids practically. But theoretically, if you substitute volume of voids is equal to 0, it can be possible. But practically, it is impossible. So, the range of void ratio is always greater than 0. Why it is not equal to 0? Because it is impossible. It is impossible to have a soil with 0 voids. And why it is greater than 0 or when it is less than 0? Sorry, when it is less than 1. If the volume of voids is less than volume of solids, then it will be less than 1. If volume of voids is greater than volume of solids, then definitely it will be greater than 1. So here, my dear students, there is another saying also, the void ratio of fine-grained soils, the void ratio of fine-grained soils is always greater than the void ratio of coarse-grained soils. Are you getting, my dear students? So remember, my dear students, the void ratio of fine-grained is always greater than the coarse-grained soils. So my dear students, I will tell a beautiful example here. Suppose if I have taken 3 beakers which are of same volume. I have taken 3 beakers of same volume. Here I have taken 1 kg of rice. This is 1 kg of rice. And this is also 1 kg of rice. Okay, all these are 1 kg of rice. because they are same beaker, same quantity, same quality. Now, this 1 kg of rice, you want to eat some idli, or if you want to have some dosa, you ask your mother, she will make this 1 kg rice into powder. So when you make this rice into powder, the volume has increased in this way. If you see the volume of the rice, it is up to here. If you see the volume of the powder, it is up to here. What could be the reason, my dear students? The reason is simple. Here, if you see in 1 kg of rice, I will tell you one example, beautiful example, my dear students. What is that here is, the simple thing you understand, my dear students, the number of voids will be less in coarse grained. That is, rice is coarse grained, my dear students. Fine grained is powder. So, if you see the size of the void, that is more in coarse grained, but the number of voids is less in coarse grained. But you see in the fine grained, number of voids are more, but size is less. So this simple logic will understand you how the water is flowing through the soil. That is the reason I have given you this example. Good evening everyone, good evening everyone. So here, my dear students, if you see the powder as fine grained and the rice as coarse grained, the void ratio of fine grained is always greater than the void ratio of coarse grained. So here, please make this statement, my dear students. Now, as we want to quickly revise, what do you mean by porosity? Porosity is defined as the volume of voids by total volume. What is the formula? My dear students, whatever I have written in the box, you can take it as a short notes. What is porosity? Volume of voids by total volume. Good evening everyone. See, students, if you really like this session, please share to your friends, which will be very fruitful in this 3 to 4 hours. Now, my dear students, porosity is defined as volume of voids by total volume. Now, as I told you already, porosity can be written as total volume is what, my dear students? Volume of voids plus volume of solids. But what is void ratio? Void ratio is defined as volume of voids by volume of solids. Again, I have an important question, my dear students. When you want to understand the physical properties of the soil, or if you want to understand the properties of the soil, will you go with porosity or will you go with void ratio? That is a simple question, my dear student. I'll tell you, for a given soil, when you take a soil sample, always remember that, student, the volume of the soil and the weight of the soil is always constant. I repeat the point, if you take a given soil, weight of soil and volume of soil is always constant. Thank you everyone. So here what I would like to tell you here is, whenever we have having porosity and void ratio, here in the denominator volume of solids is constant. But in porosity, volume of numerator is also varying and denominator is also varying. So when two terms are varying, it is difficult to determine. Whereas in void ratio, you will have only one parameter varying, that is volume of voids. So remember, my dear students, void ratio is defined as the ratio of volume of voids to the volume of solids. And porosity is defined as volume of voids by total volume. Now, my dear students, they can ask you, what is the relation between porosity and void ratio? The relation between porosity and void ratio is given as N is equal to E upon 1 plus E. Now tell me, what is the range of porosity, my dear students? The range of porosity is simple basic maths. If you consider the numerator is less than denominator, because 1 plus something is always greater than this. When numerator is less than denominator, definitely N will be less than 1. And you know that void ratio will never be equal to 0. So the porosity is defined as, the range of the porosity is defined as 0, N less than 1. So this is what I would like to add. Now, my dear students, we have another important formulas. One is air content. What do you mean by air content? VA upon VV. Now, my dear students, what is VA upon VV? Air content is defined as the ratio of volume of air upon volume of voids. Where do you find air, Amma? Air is found in voids. So here, my dear students, what I would like to tell you is, in fully dry state, when I consider fully dry state, what will happen? The voids are completely filled with air. So in this case, volume of air will be equal to volume of voids and the air content will be equal to 1. Now, my dear students, if I consider fully saturated state, that is when the voids are completely filled with water, in this case, volume of air will be equal to 0. And remember, air content will be equal to 0. Now, immediately you can ask me, what is the range of air content? The range of air content is 0 less than or equal to air content less than or equal to 1. My dear students, here equal to has come. Why? Because in fully saturated state, air is 0. In fully dry state, voids are completely filled with air. So this is how you have to remember. Simple way how to remember is air is present in voids. So how much air content means how much air is in voids. So volume of air by volume of voids is nothing but air content. Similarly, my dear students, if you want to understand degree of saturation is defined as volume of water upon volume of voids. So my dear students, what do you mean by degree of saturation? Please write down. Degree of saturation is defined as volume of water upon volume of voids. Good evening, Abhishek. Now here, what is volume of water by volume of voids? See, my dear students, in fully saturated state, volume of water will be equal to volume of voids, and in fully dry state, volume of water will be equal to 0. So remember, my dear students, I would like to tell you the range of degree of saturation is 0 less than SR less than or equal to 1. So the range of the degree of saturation is 0 less than or equal to SR less than or equal to 1. So here, my dear students, when they ask you what is air content plus degree of saturation, air content plus degree of saturation is equal to 1. My dear students, if they ask you in percentile, you have to just multiply with 100. And another important thing is, we have a term called percentage of air voids. What do you mean by percentage of air voids? Sir, already you have explained what is air content. Then what is the difference between air content and percentage of air voids is, when you speak about the air content, you speak about the voids. When you talk about the percentage of air voids, you talk about the entire volume. So my dear students, percentage of air voids is defined as volume of air upon total volume, and this can be written as volume of air upon volume of voids. I am just multiplying and dividing with volume of voids, and this can be written as volume of air upon volume of voids and volume of voids by total volume. And what is volume of air by volume of voids? It is nothing but air content. And what is volume of voids by total volume? It is nothing but porosity. So my dear students, the percentage of air voids is written as porosity into air content. It is defined as the porosity into air content. And here also, what will be the, good evening Rakesh, good evening. What is the range of percentage of air voids is? It is 0 less than or equal to Na less than or equal to N. So whatever I have written in the box, please take it as a short notes, my dear students. So here, when air content is 0, this will be equal to 0, and air content is equal to 1, it will be equal to N. So here, percentage of air voids is 0 less than or equal to Na less than or equal to 1. Now, my dear students, I would like to tell you another important thing, another important formulas. What do you mean by water content? Water content is defined as the ratio of weight of water by weight of solids. What is water content, my dear students? Water content is defined as the ratio of weight of water to the weight of solids. Now, similarly, you can ask me, what is the range of water content, my dear students? So here, when I talk about the range of the water content, when you take fully dry state, my dear students, the water will be 0. So weight of water will be 0. So it will be, the range of water content is greater than or equal to 0, my dear students, in dry state, the weight of water will be 0. Remember that. But when it is greater than 1, simple thing, my dear students, if you take a lake or if you take a pond or if you take a water bodies, the amount of soil will be less and the amount of water will be more. In such case, the water content can be more than 1. So what is the range of water content is? The range of water content is always greater than or equal to 0. My dear students, it's a sincere request for all of you. If you feel this session is useful for you, please share to your friends who will enjoy this session, and definitely they will get a good mark in GATE 23. Now, my dear students, you have already told that water content is defined as weight of water upon weight of solids. Now, how do you determine the water content? How do you determine the water content? This is very important, my dear student. How do you determine the water content? The most accurate method, this is one of the previous GATE question, my dear student. One is the most accurate method, that is the most accurate method is the oven drying method. What is, sir? The oven drying method is the most accurate method to determine the water content. And here he has given the formula as W minus WD upon dry weight. Now simply, if the entire soil is kept in the oven and if you keep it for how much duration, they can ask you, my dear students. They will keep a duration for 24 hours and the temperature maintained is 105 to 110 degrees centigrade. So whenever, my dear students, which is the most accurate method to determine water content is, the most accurate method to determine water content is oven drying method. And remember, my dear students, but the only disadvantage in oven drying, sir, you say it is accurate, but I have to wait for 24 hours. That is a very important thing. So in this case, you are looking for the fastest method. You can say that which is the quickest method to determine water content is calcium carbide method. Calcium carbide method is the quickest method and it hardly takes 5 to 10 minutes, my dear student. And they can ask you one more thing, my dear students. What is the gas released in calcium carbide method? The gas released in calcium carbide method is acetylene, that is C2H2. You can remember this also in 1 mark questions. So which is the most accurate method to determine the water content? Oven drying method. Which is the quickest method to determine water content is calcium carbide method. And what is water content is weight of water upon weight of solids. And remember, the range of water content is always greater than or equal to 0. Now, my dear students, it is my promise. You remember this slide and definitely you will get 2 marks in GATE, student. So please remember this slide, or if you have some next slide, whatever the slide which I am going to tell, take a screenshot or whatever. This is definitely you will get a question, sir. Now, my dear students, there was a question asked, the relation between void ratio, water content and specific gravity, and SR is known as degree of saturation. What is specific gravity? I will explain you later, my dear students. The relation between void ratio, water content, specific gravity and SR is given by the formula E is equal to water content to G upon SR. Next thing, my dear students, you should know gamma is equal to gamma W into G plus ESR upon 1 plus E. Okay, my dear students? So here, this is the formula for unit weight. What is gamma means? They can ask you gamma as bulk unit weight, or they call gamma as the unit weight of the soil. And remember, my dear students, gamma will become gamma sat. No, see, most of the people will think that gamma will become gamma D. Based on the state of the soil, the gamma will change. If it is saturated state, we call it as gamma sat. In this case, my dear students, SR will be equal to 1. In dry state or gamma D, the degree of saturation will be equal to 0. So simply put the value of SR is equal to 1 here and SR is equal to 0. So my dear students, the saturated unit weight is given by the formula gamma W into G plus E upon 1 plus E. This is the formula for saturated unit weight. Similarly, my dear students, they can ask you what is dry unit weight. Dry unit weight can be taken as gamma W into G upon 1 plus E. This is another important formula, my dear student. There is only one unknown. This formula is very important. And remember, my dear students, whenever you are solving the problem, if you can implement this formula, you can easily solve the problem, because unit weight of water, if you take the unit weight of water, it can be written as 1 ton per meter cube, or it can be 1 gram per cc centimeter cube, or 9.81 kilonewton per meter cube. So this is the value of gamma W. And remember, my dear students, gamma D can also be written as gamma upon 1 plus water content. Gamma D can also be written as gamma upon 1 plus water content. Definitely, my dear students, these formulas will help you. And we also have a typical formula. Gamma is equal to gamma D plus SR into gamma sat minus gamma D. This is a derived formula, my dear students. So no need to remember this, but to have just to have a look at that formula, you should. And another important formula is gamma D can be written as bulk unit weight upon 1 plus water content. Okay, so this is another important formula. So I quickly revise the top formulas. Good evening, Chandrababu. So here, what is void ratio? Void ratio is defined EWGSR. E is equal to WG by SR. What is gamma? Gamma is known as the bulk unit weight. Gamma is equal to gamma W into G plus ESR upon 1 plus E. And gamma is equal to gamma D plus SR into gamma sat minus gamma D. And remember, see, no need to remember these two formulas again, my dear student. You remember gamma formula? Substitute SR is equal to 1, you will get gamma sat. Substitute SR is equal to 0, you will get the dry unit weight. And this is another important formula, my dear student. Dry unit weight is equal to bulk unit weight upon 1 plus water content. I will give you 10 seconds. Just take this and write these important formulas. This will help you a lot, my dear student. Students, if you are really interested with this session, please share to your friends and they will be benefited. And another important formula in GATE, what we have observed is, suppose, my dear students, there is a fill. You have to fill this. If you assume this as fill, and you are bringing the soil from a borrow pit. So you are bringing a soil from borrow pit and you are trying to fill this soil, fill the soil here. So in this case, if I take the gamma 1 as the unit weight of the fill, water content as WC1, and if you take here, E1 as the void ratio. Now, my dear students, you should remember here, gamma D, dry unit weight, is taken as, similarly, borrow pit, I take it as gamma D2 or E2 if I take, and V2. And if I take here volume, what is gamma 1? Bulk unit weight. What is water content? WC1. E1 is the void ratio. V1 is the volume. So gamma D can be written as weight of solids upon total volume, my dear student. I told you already, for a given soil, weight of solids is always constant. So gamma D is inversely proportional to volume. So from this relation, I have written that gamma D1 by gamma D2 is equal to V2 upon V1. And remember, my dear students, as I told you in the first slide, total volume can be written as volume of voids plus volume of solids. If I take here column volume of solids common, it can be written as 1 plus VV upon Vs. Now, my dear students, what is VV upon Vs? It is nothing but void ratio. So total volume can be written as Vs into 1 plus E. For a given soil, total volume of solids is constant. So from this, volume is proportional to 1 plus E. So remember, my dear students, if they ask you, you have to write this formula. Gamma D1 by gamma D2 is equal to V2 by V1 upon 1 plus E2 by 1 plus E1. They will ask you another important thing also, my dear students. This is a very important formula for borrow pit and fill problems. Usually in GATE exam, my dear students, they will ask you the borrow pit. Thank you. They can ask you for a dry unit weight and volume and void ratio. This is the important formula, my dear student. See students, I might be somewhat fast, but as it is a quick revision, we are discussing the important formulas, and please take a note. Whatever I have keep in the box, please write it as a short notes. Okay. Now my dear students, they can ask you extra amount of water to be added also. They can ask you another important question. What is the extra amount of water to be added? If they ask you what is the extra amount of water to be added, this type of question, please remember this formula, my dear students. You can write it as gamma D1 V1. Extra means wherever the water content is higher minus water content lower. So this is the extra amount of water you have to do. How this formula came is water content is defined as weight of water by weight of solids. And you can write here weight of water is equal to water content into weight of solids. And remember, weight of solids can be written as gamma D is equal to weight of solids upon total volume. So weight of solids can be written as gamma D into V. So from this, actually this formula, why you are subtracting here is because he has used the word extra. If extra is not given, no need to. राकेश वर्मा मेरे को हिंदी मेरा इंस्ट्रक्शन कैसा है ना इधर आई हैव टू एक्सप्लेन इन द इंग्लिश बट आई विल एक्सप्लेन यू एज यू हैव रिक्वेस्टेड आई विल एक्सप्लेन यू इन वेरी स्लोली विथ इंग्लिश ओके now what is the extra amount of water to be added here is gamma d1 v1 into water content 1 minus water content 2 will give you the extra amount of water to be added in ton. They can ask you, my dear students, they can ask you in tons or they can ask you in gram per cc. So based on here gamma d value, that value will be taken into account. Okay. Now my dear students, what do you mean by specific gravity? Specific gravity is defined as the ratio of unit weight of solids to the unit weight of water. Actually, specific gravity is a constant. This is usually useful in automobile industry. Suppose if you are using different fuels, specific gravity has this application. So to convert from one unit to the other unit, you will use this specific gravity. And specific gravity is determined by an instrument known as pycnometer. And you have another important thing, Amma. This specific gravity is also known as true specific gravity. This specific gravity is also known as what? True specific gravity. But similarly, we have another case is mass specific gravity. That is mass specific gravity. And remember, mass specific gravity is not always constant. But true specific gravity is always constant and it varies between 2.6 to 2.85. So specific gravity can be written as gamma by gamma W, or it can be gamma sat by gamma W, or it can be gamma D by gamma W. Sir, you will ask me one doubt. Sir, out of these three formulas, which formula I have to use? So my dear students, if it is a saturated state, you have to use gamma sat. If it is a dry state, you have to use gamma D. If it is a bulk state, you have to use gamma. So please remember this. Based on the state of the soil, the mass specific gravity will be. And remember, true specific gravity is always greater than the mass specific gravity. True specific gravity is always greater than the mass specific gravity. And remember, true specific gravity is given by the formula. You can write it as W2 minus W1 upon W2 minus W1 minus of W3 minus W4. You can ask me what is W1, what is W2, what is W3. Weight, this is weight of pycnometer. Weight of pycnometer plus solids is W2. Okay. What is W3 is weight of pycnometer plus solids plus water. And what is W4 is weight of pycnometer plus full of water. So this is what we are going to discuss in properties of soil. So quickly, within 5 minutes, we will quickly revise the entire properties of soil chapter. How do you represent a soil? Soil can be represented as 3-phase system and 2-phase system. What is the range of, how do you define void ratio? Remember, void ratio is defined as the ratio of volume of voids to the volume of solids. And the range of void ratio is always greater than 0. The void ratio of fine grained is always greater than the void ratio of coarse grained. Porosity is defined as volume of voids to the total volume. The relation between porosity and void ratio is defined as N is equal to E upon 1 plus E. Air content is defined as volume of air upon volume of voids. Degree of saturation is defined as volume of water by volume of voids. Sir students, I might be fast, which I have completed now. I am quickly revising. Air content plus degree of saturation is always equal to 1. And the percentage of air voids is defined as volume of air upon total volume. And the range of percentage of air voids is 0 Na less than or equal to N. And remember the important relations between the formulas in properties of soil. E is equal to Wg upon Sr. Gamma is equal to gamma W into G plus ESR upon 1 plus E. Gamma sat is equal to gamma W into G plus E upon 1 plus E. Gamma D is equal to gamma W into G by 1 plus E. Gamma D is equal to gamma upon 1 plus water content. And we have borrow fill and pit fill problems. Gamma D1 by gamma D2 is equal to V2 by V1 is equal to 1 plus E2 by V1 plus E1. Water content is defined as the weight of water upon weight of solids. The most accurate method is the oven drying method. And the quickest method for determining the water content is the quickest method to determine the water content is the calcium carbide method. And you remember, yes, I'll definitely give you Rakesh, don't worry. And remember, my dear students, the true specific gravity is always greater than mass specific gravity. And remember one more thing, for a given soil, unit weight of solids is always constant and unit weight of water is always constant. And remember, specific gravity is given by the picnometer formula W2 minus W1 upon W2 minus of W1 minus of W3 minus W4. Okay? Now, coming to the next chapter, it is a theory chapter. What do you mean by origin? Sir, why do you want to study about the origin of soils? If you ask me, based on the nature of the soil, the properties are going to vary. So, my dear students, the typical question, how the soil is derived? Soil is derived from a Latin word called solum. Actually, the study of soil is known as pedology, or the formation of soil is known as pedogenesis. So, my dear students, soil is formed by a cycle. Suppose if there is a human body, there will be a cycle. Similarly, soil is formed by a cycle known as geological cycle. Soil is formed by a cycle known as geological cycle. Now, what do you mean by geological cycle? What do you mean by geo? Geo means nothing but earth. So, the soil is formed by a cycle known as geological cycle. What are the stages of geological cycle? They can ask you in assertion and reasoning. The first stage is the weathering. Again, in weathering, we have physical weathering and chemical weathering. Physical weathering is due to the natural effects and chemical weathering is due to the oxidation, hydration and all. And after weathering, transportation, the soil gets withered and it can be transported either by means of air, water or any other means. After transportation, it will get deposited and after deposition, it forms upheaval. Sir, most of the students when I am teaching, sir, they will ask me what do you mean by upheaval? Upheaval, according to the English meaning, it is nothing but rise in earth's crust. Means a hump, rise in earth's crust is nothing but the upheaval. This is the English meaning of it. I'll tell you in a diagram here. Suppose if you have taken a soil, my dear students, this soil is if you take this as a rock, this rock is withered and it gets transported. After transported, it gets deposited. After that, the soil gets like a hump. This is called upheaval. So the question here is, how do soils are formed? Soils are formed by weathering of rocks and decomposition of organic and inorganic matter. Here, what is the cycle associated with soil is geological cycle. And what are the stages in geological cycle? Weathering, transportation, deposition and upheaval. Now, see here, they can ask you what is the most fertile soil. The most fertile soil is nothing but the alluvial soil. If anyone asks you which is the most fertile soil is alluvial soil or the soil which is deposited in river. They can ask you whatever the soil which is deposited in wind, then it is called as aeolian soils. Sir, these aeolian soils, if you consider the examples, they are sand dunes and losses and these are observed in deserts. These are observed in where? Deserts. And similarly, if you consider, sir, similarly, if you consider gravitation, soils which are deposited by gravitation, here gravitation or due to self-weight, the soil gets deposited. These are called, anyone can you tell me? This soil is known as colluvial soils. So this is the entire theory part. So soils formed by gravitation soils are called colluvial soils. And they can ask you another important, glacier deposited soils. The soils which are deposited in snow are called as glacier deposited soil. Example for glacier deposited soils are drift, till. These are the soils where you find in Kashmir or Switzerland and all. And gravitation soils, you can take the example as talus. These are observed in mountains. Are you getting me? So here actually soils are classified broadly into two types, my dear students. One is the residual soil. Soils are broadly classified into two things. One is the residual soil and other one we have is the sedimentary soil. What is the two cases where we are classifying? One is the sedimentary soil and other one is the residual soil. So whenever they ask you what is residual soil is, soils which remain on the parent rock without transportation is known as residual soils. Black cotton soils and laterite soils are the examples of residual soils. And what do you mean by sedimentary soils? My dear students, when I talk about the sedimentary soils, soil particles created at one location and finally deposit at another location is known as sedimentary soils. And another important thing they can ask you, which forces are predominant? Gravitational forces are predominant, means more in gravel and sand. Surface, chemical and electrical forces are predominant in fine-grained soils. And if they can ask you also, what do you mean by warwood clay? Warwood clay means it contains alternate layers of clay and silt. Loam means a mixture of sand, silt and clay. And similarly, they can ask you morum, gravel mixed with red clay. So these are the things which you will be discussing about the origin of soils. The next topic I would like to discuss here is the soil structure. What do you mean by soil structure? If anyone asks you, what do you mean by soil structure is geometrical arrangement of soil particles. The geometrical arrangement of soil particles is nothing but soil structure. The geometrical arrangement of the soil particles is nothing but the soil structure. They can ask you these things also, my dear students. See students, there is a property called thixotropy. I'll tell you a best example for thixotropy. Suppose if you have, do you know about the elasticity? You know the property of elasticity. If you want to expand it, if you have expanded something, a rubber, and similarly slowly it will move its original position. Okay, now what do you mean by thixotropy is the phenomena of regain of lost strength, whatever the strength. See, actually due to remolding, when the soil gets remolded, there will be a loss of strength. When the soil gets remolded, there will be some loss of strength. So here what I would like to tell you is, due to remolding, what will happen? Due to remolding, what will happen is loss of strength will happen. So what is thixotropy is the phenomena of regain of lost strength. Whatever the strength which is lost, it will regain, but it will not regain immediately. It will take a passage of time. That is known as thixotropy. I remember, you write down again, my dear students, the phenomena of regain of lost strength with the passage of time with no change in water content. You have to write this word, no change in water content. So that is known as thixotropy. Remolding causes loss of strength. Now, my dear students, there can be what are the types of the structures? When I talk about what are the different types of structures? When I talk about the different types of structures, we have first one is single grain structure. First one is what, my dear students? We have is the single grain structure. And the second one we have is the honeycomb structure. And the third one we have is the flocculated structure. And the fourth one we have is the dispersed structure. So whenever you talk about the single grain structure, what if you assume the soil particles as spheres, they can be arranged in a cubical array. Means if the soil particles are assumed in the form of spheres and they are arranged in a cube, here in this case, the maximum void ratio means when will be the void ratio will be maximum, my dear students? the void ratio will be maximum in loosest state. The void ratio will be maximum in the loosest state and it will be equal to 0.91, and the void ratio will be minimum in the case of densest state, because my dear students, they will not give you the maximum or minimum. Sorry, they will not give you loosest state or densest state. If the void ratio is maximum, indicates that it is a loose state. If the void ratio is minimum, indicates densest state. And these are the standard values you have to remember in case of cubical arrangement. Now, my dear students, what is a honeycomb structure? And it is a very dangerous structure. When you talk about the honeycomb structure, this was a previous GATE question also. Honeycomb structure is observed in which type of soils? It is observed in fine sands and also it is observed in silts. So what do you mean by honeycomb structure? It means if you just disturb the structure will entire collapse. That is the beauty of, that is the bad work of honeycomb structure. So whenever you have honeycomb structure, try to avoid this. Remember, honeycomb structure is observed in which type of soils? It is observed in the fine sands and silts. And under small vibration and shocks, the entire structure will collapse. And what do you mean by flocculated structure? Flocculated structure will be something I'll give you a best. See, this will be of this kind. Here, flocculated structure will be formed due to edge to face orientation. Edge to face itself indicates that there is attraction. When there is an attraction, the shear strength will be more. It has high shear strength, low compressibility and high permeability. Why it is having high permeability means the size of the void will be more. So if anyone asks you what is flocculated structure or where do you observe this structure is, flocculated structure is observed in clays. And how do flocculated structure is formed? It is formed due to the edge to face orientation. It has high shear strength, low compressibility and high permeability. What is disperser structure? It is observed due to face to face orientation, okay, or edge to edge orientation. Here in disperser structure, if it is having high shear strength, it will have less shear strength. If it is having high permeability, it will have low permeability. If it is having low compressibility, it will have high compressibility. And disperser structure is observed in remolded clays. Disperser structure is observed in which clays? Remolded clays. This can be a question, my dear students. Remember, honeycomb structure is observed in fine sands and silts, and you have to avoid this structure. Flocculated structure is observed in clays. It has high shear strength, low compressibility and high permeability. So this is what about we are going to discuss about the types of structures. Next, my dear students, this is another important thing. They can ask you in clay mineralogy, we have seen 2 times in GATE. They have asked 2 times in GATE about the clay mineralogy. I am telling you, name the clay mineral with no swelling and no shrinkage, or with less swelling and shrinkage. Name the clay mineral, or they can ask you, name the stable clay mineral. What do you mean by, when do you say that a clay mineral is stable? Is when there is less swelling, or you can say no swelling. Or swelling is nothing but bulging. When there is no swelling or shrinkage, no swelling or shrinkage. So whenever they ask you which is the most stable clay mineral is, the most stable clay mineral is nothing but the kaolinite. Name the clay mineral which is stable is nothing but kaolinite. Similarly, they can ask you, name the clay mineral. They can ask you, name the clay mineral which is formed by potassium ions. They can ask you, name the clay mineral which is formed by the potassium ions. And it was a previous GATE question. Can anyone quickly answer me? Name the clay mineral which is formed by potassium ions. Sir, name the clay mineral which is formed by potassium ions is nothing but illite. Okay. And name the clay mineral which has highest swelling. Name the clay mineral which is having highest swelling is the clay mineral, or name the clay mineral which is having high swelling is nothing but montomonolite, because the structure is formed due to the hydrogen water molecules. That is the reason montomonolite has the highest swelling. Or they can ask you what is clay mineralogy. Name the clay mineral which is stable or which is having no swelling and shrinkage. That is nothing but kaolinite. And name the clay mineral which is having high swelling and shrinkage is montomonolite. And name the clay mineral, this is a previous GATE question. Name the clay mineral which is formed by potassium ions. It is nothing but illite. And remember, my dear students, halosite behavior is similar to kaolinite. If they ask you what is the behavior of halosite, means the behavior is similar to kaolinite. So it will also assume as stable mineral. And remember, my dear students, there is a concept called specific surface area. My dear students, usually when I teach, I usually ask the students, what is the difference between surface area and area? Can anyone quickly answer me? What is the difference between area and surface area? What is the area of rectangle and what is the surface area of rectangle? I'm quickly answer me, my dear students. I'm talking about specific surface area. What do you mean by surface area and area? Remember, my dear students, the area and surface area will be same for two-dimensional bodies. Only for three-dimensional bodies, the area and surface area will come into picture. You can know in case of cube or cuboid or rectangle or square, the area in rectangle and square, the area and surface area will be same. So what exactly specific surface area means? It is given by the units centimeter square per gram or meter square per gram. So from these units, you can understand what exactly is specific surface area. Specific surface area means it is the surface area of soil particles present in unit weight. So remember, there is an important statement here, my dear students. Finer the soil, they can ask you in they can ask you in objective questions. Finer the soil, higher the specific surface area. Please remember this point, my dear student. This was a previous GATE question also. When do you say that? What is the units of specific surface area? It is the surface area of soil particles present in unit weight. Finer the soil, higher the specific surface area. And remember, if this session is really helpful, you can share this session. And also, my dear students, in Bangalore and in Vijayawada also, we are providing the offline coaching. So if anyone is really interested, you can visit our office at the near Southern Circle at Bangalore, and at Vijayawada we are having our center at Bench Circle. So this is what I would like to tell you. And coming to the specific energy, finer the soil. Suppose if you take the specific surface area, remember that specific surface area of clay is more than specific surface area of silt, and silt will be more than sand, and sand will be more than gravel. If there is colloids, colloids will have more specific surface area compared to clay. So why I am telling you here is finer the soil, higher the specific surface area. Remember, my dear students, I hope these sessions are helpful for you. I will quickly revise the soil structure concept. What do you mean by soil structure is the geometrical arrangement of soil particles in a soil mass is known as soil structure. And we have different types of soil structures like flocculated structure, dispersal structure, honeycomb structure, and also single grain structure. The maximum void ratio is 0.91 in cubical array and minimum void ratio is 0.35. Void ratio will be maximum in loosest state and void ratio will be minimum in denser state. And remember, honeycomb structure is avoided. Name the clay mineral which is formed by potassium ions is elite. Name the stable clay mineral is kaolinite, or you can say halosite also. Name the clay mineral with the highest swelling is montmorillonite. Finer the soil, higher the specific surface area. Specific surface area is the surface area of soil particles present in unit weight. So my dear students, we are coming live every day for different branches also. So really this quick revision is initiated to help the students to come across the short notes. And we have so many, one of my friend in mechanical also production engineering, we have Mr. Dr. Vijay Kumar, sir. He is an excellent professor in production engineering. Whenever you have an opportunity, he is having his session on January 22nd. Definitely you can visit his session and he will help you production, which is the maximum weightage for mechanical engineering. He is an excellent professor, and try to attend the sessions daily. Okay, whoever in which department you are in civil, we have very good team with Pratik Mishra and Ankit Dongrial. Ankit Dongrial will be teaching you about the foundation engineering. So we are here to help you, my dear students. I will tell you a small saying. In Abraham Lincoln, he has given one saying, my dear student. What is the saying is, if you want to do a work, if you want to cut a tree, If it is taking 6 hours of time, 4 hours you have to use your time for sharpening the axle. Similarly, if we are teaching you the short notes, we will also do our homework. So attend this session, grab the knowledge, utilize this opportunity and share this knowledge to your friends. And remember, when you share this knowledge just before the GATE exam, definitely your friends will feel happy after the GATE exam, because the fruits will be reached once he scored best ranks in the GATE. Thank you, my dear students. Next topic, next chapter we are going to discuss here is the index properties. Next topic here I am going to discuss is the index properties. So what exactly do you mean by index properties? So index properties are useful for classifying and identifying the soil. Why do you want to study about the index properties of soil? Index properties are useful for classifying and identification of soil. Okay. Whenever you talk about the engineering properties of the soil, so my dear students, if this session is really helping you, please like and share this session. So here what I would like to tell you here is, whenever you are talking about classifying and identifying the soil, okay, what are the engineering properties of soil? Okay, what are the engineering properties of soil? Now the engineering properties of the soil are nothing but permeability. The engineering properties of the soil are permeability, compressibility, shear strength, and these are some of the engineering properties, my dear student. So why do you want to study about index properties? If anyone asks you, these are separate chapters, I will discuss separately, my dear student. What do you mean by index properties? Index properties are useful for classifying and identifying the soil. And remember, my dear students, when I talk about the classifying and identifying the soil, so here soils are broadly classified into two types. One is fine-grained soils and other one we have is the coarse-grained soils. So which are useful for fine-grained soils and which are useful for coarse-grained? In coarse-grained, we will be using sieve analysis. In coarse-grained, for classification of coarse-grained soils, the concept used is sieve analysis. And for the classification of fine-grained, we will be using the consistency limits, or consistency limits are also known as Atterberg limits. We will be using consistency limits, or also we can use the sedimentation analysis for classifying the fine grain. I hope you are clear. There can be a question asked, how do you classify the fine grained soils? Fine grained soils are classified with the help of consistency limits or Atterberg limits or sedimentation analysis. They can, and coarse grained soils are determined by sieve analysis. So before talking about the sieve analysis, consistency limits and Atterberg limits or sedimentation analysis, we have a graph, my dear student. If I consider a graph here, there is a graph between particle size, there is a graph between, 1 second, my dear student. There is a graph here. What is the graph here is, the graph is particle size dia. Graph is drawn with, sir, my dear students, I have told in my previous sessions also, whichever the known quantity will be drawn on x-axis and the percentage finer will be drawn on in the y-axis. Usually when you take a graph, known quantity will be on x-axis and unknown quantity will be on y-axis. So if I see the graph here, the graph looks something like this, my dear student. The graph will something look like this. Soil is called, this graph represents well-graded soil. Okay, that is the shape they can ask you is S shape. And what is this soil represents is, this graph represents uniformly graded soil. Okay, and it is shape here is steep shape. And they can ask you, what is this graph indicates? It is hump, or you can say poorly graded or gap graded soil. I will tell you what is poorly graded, well graded. So here from the graph, if all the particle sizes are there in that soil, then it is called as well graded soil. So S shape represents particles of all sizes. If all the sizes are present, particles of all sizes are present, then it is well graded soil. Some particle sizes are missing, then it is called poorly graded. Suppose if you see here and here, some particle sizes will be missing. That is called poorly graded. And if you see the steep, almost all the particles are of same size, then you will talk about the uniformly graded soil. So remember, what is well graded soil? All the particles are of same size, uniformly graded. All the particles of all sizes are present, then it is well graded. Some particle sizes are missing, then it is called poorly graded. So my dear students, there are some coefficients you have to remember. One is the coefficient of curvature, which describes about the shape of the curve. So you are telling a shape for well graded soils. So when we talk about the coefficient of curvature, that is called CC. So CC is given by the formula d square 30 upon d60 into d10. What is d60 into d10? So coefficient of curvature is given by d square 30 upon d60 into d10, and d10 is known as effective size. They can ask you, what do you mean by effective size? Now immediately, my dear friends, you will ask you, what do you mean by d30, what do you mean by d60 and d10? Here, what do you mean by d30, d60 or d10 is, d30 is nothing but the particle size, where 30%, it is the size of the sieve. Whatever D indicates, first of all, it is the size of the sieve in mm, where 30% of the particles are passing. If it is D60 means it is the size of the sieve where 60% of the particles are passing. If it is D10 means this is known as effective size, where only 10% of the soil particles are passing. So whenever I talk about the coefficient of curvature is defined as d square 30 upon d60 into d10. And remember, coefficient of uniformity is defined as d60 by d10. And remember, why do you want to study about coefficient of uniformity is to understand the particle size range. If you take a group soil, from which particle size to which particle size the sample is cutting, that you can be telling by coefficient of uniformity. And for well graded sand, Cu will be greater than 6, and for well graded gravel, Cu will be greater than 4. And if you take for well graded soils, Cc should lie between 1 and 3. Now my dear students, whenever I am talking about Cu and Cc, I am talking about well graded soil only. Whenever you want to know about poorly graded, if any one of the condition is not satisfied, if the conditions of Cu and Cc are not satisfied, then itself you can say that the soil is poorly graded. For a soil to be well graded, both the conditions of Cu and Cc should be satisfied. I hope you are clear. Now coming to the consistency limit. Consistency limits are Atterberg limits are determined by what are consistency limits are Atterberg limits. First, let me draw the graph. There was a graph drawn between volume. And also the water content. A graph is drawn between water content and volume. If you see here, this point is known as Vd. Okay, and this is called shrinkage limit. And if you see here, this is called as the plastic limit. And if you see the graph here, it is liquid limit. And if the volumes at their respective positions will be, it will be volume at plastic limit, and this will be volume at liquid limit. So here what I would like to tell you, my dear students, here see, this is liquid state, okay, this is plastic state, and this is semi-solid state, and this is solid state. So there was a, see students, from the diagram, as you move to the right side direction, the values will increase. So you can clearly write that liquid limit is greater than, plastic limit is greater than shrinkage limit. Okay, so here you can say liquid limit, plastic limit and shrinkage limit are the one of the important things. So what actually, why I have written, so there was a previous gate question, which is the increasing order or decreasing order. Liquid limit will be more than plastic limit and shrinkage. So coming to the first concept, we'll discuss about individually. What is WL called, my dear students? Liquid limit. Okay, name the apparatus which is determined for liquid limit is nothing but cascades apparatus. What do you mean by a liquid? A liquid, it will have, means A liquid is easy to flow. You can say what is liquid limit is, it is the minimum water. What do you mean by liquid limit is, if you cross this zone, it will be changed into liquid state. So what is liquid limit is, it is the minimum water content at which the soil has small shear resistance. If it is having small shear resistance, then it is called liquid limit. If it is zero shear resistance, means it will cross the liquid limit and it flows like a liquid. Coming to the plastic limit, what do you mean by plastic limit? It is the minimum water content at which a soil can be rolled into a 3 mm diameter. So when you add water into the soil and if you make a rope of 3 mm diameter, it will not break or crumble. That is known as plastic limit. And what do you mean by shrinkage limit is, so my dear students, wherever you see here, the volume is varying linearly. But here if you see, the volume is constant. So they can ask you, say that, what do you mean by shrinkage limit is? Shrinkage limit is the minimum water content at which the soil is fully saturated, or it is the water content at which any further loss of moisture, even though there is some loss of water content due to loss of moisture, but the volume will never change. That is called shrinkage limit. So what are Atterberg limits? Liquid limit will have minimum shear resistance. Plastic limit means a soil can be rolled into 3 mm diameter without breaking or crumbling. WS shrinkage limit means it is the minimum water content at which further loss, at which the soil is fully saturated, or it is the maximum water content at which even though there is a loss of moisture, there will not be any change in dry volume. Is it clear, my dear students? So here from this, liquid limit is always greater than plastic limit. And one more thing, my dear students, if you don't remember this, this graph you have to remember, because what is the state between liquid limit and plastic limit? It is plastic state. What is the state between plastic limit and shrinkage limit? Semi-solid state. What is the state below shrinkage limit? Then it is solid state. Based on this graph also, lot of problems can be solved, because they will tell you that the change from liquid limit to dry state is so and so. The change from plastic limit to shrinkage limit will be given. Similarly, they can ask you what is shrinkage limit. And remember here, shrinkage limit is important formula. Shrinkage limit is given by the formula E by G or 1 by Gm minus 1 by G. So these are the formulas for shrinkage limit. These are the formulas for shrinkage limit. One formula is Ws is equal to E by G, or another formula is 1 by Gm minus 1 by G. And one more thing, my dear students, please like this session and share this session, my dear student. So here what I would like to tell you, there are different terms also. One thing is volumetric shrinkage, and also, what do you mean by volumetric shrinkage? So the change in the change in volume, if suppose you are considering the change in volume from liquid limit to shrinkage limit, the change in volume expressed in terms of dry volume is known as volumetric shrinkage. They can also ask you, what do you mean by shrinkage ratio? This is also important now. This is also important. And shrinkage ratio, in simple words, shrinkage ratio is nothing but volume change. What do you mean by shrinkage ratio, my dear students? It is defined as the volume change. Shrinkage ratio is defined as the volume change expressed in terms of dry volume. Volume change expressed in terms of dry volume to the corresponding change in water contents. Again, I am remembering, my dear students. So here if you write the shrinkage ratio is the change in volume, the change in volume which is expressed in terms of dry volume to the corresponding change at liquid volume, it will be liquid limit. At dry volume, it will be equal to shrinkage limit. So shrinkage ratio can be written as volume change expressed in terms of dry volume to the corresponding change in water contents. And remember, my dear students, shrinkage ratio is nothing but the mass specific gravity at dry state. Please remember these formulas. A famous problems are asked in GATE. So shrinkage ratio can be also written as gamma D by gamma W. So what do you mean by volumetric shrinkage? Volume change expressed in terms of dry volume. And what do you mean by shrinkage ratio is volume change expressed in terms of dry volume to the corresponding change in water content. And what do you mean by shrinkage ratio? It is the volume change expressed in terms of dry volume to the corresponding change in water contents. Now, my dear students, we have different plasticity index. So, if you talk about the plasticity index, or you can say plasticity index, what do you mean by plasticity index? Here is plasticity index is given by the formula liquid limit minus plastic limit. Remember, my dear students, plasticity index is given as liquid limit minus plastic limit, and shrinkage index is given by the formula plastic limit minus shrinkage limit. And remember, toughness index is given by the formula IP upon IF. Toughness index is given by plasticity index upon IF. What do you mean by IF here? What do you mean by IF here is, sorry students, here one second. Here it is denoted as IS. Okay. What is I? Here it is flow index. Why do you want to study about flow index is, flow index gives you idea about the shear strength of the soil, and it is given by the formula W1 minus W2 upon log N2 by log N1. Okay, actually there is a graph drawn between these students. Actually it is a decreasing graph. If the water content is more, okay, the number of blows will be less. If the water content is less, the number of blows will be more. So if the graph is drawn between water content and number of, okay, and number of blows, here it can be N2 and N1. The slope of this flow curve, the slope of flow curve, this curve is known as flow curve. The slope of the flow curve is known as flow index, and flow index is given by the formula W1 minus W2 upon log N2 by log N1. So this is very important, my dear student. This is the flow index formula, and we also have liquidity index. Liquidity index is given by the formula W minus WP upon IP. And remember, my dear students, similarly we have consistency index also. Consistency index, if I talk about the consistency index is given by the formula WL minus W upon IP. And remember, you have to remember this is called consistency index, and you can say consistency index plus liquidity index is always equal to 1. And you can also say, students, at liquid limit, if they ask you at liquid limit, IC consistency index will be equal to 0. At plastic limit, consistency index will be equal to 1. And at shrinkage limit, IC will be greater than 1. So IC, so these things, how do you got these values is, just substitute here WL. If you substitute instead of water content WL, WL minus WL is 0. If you substitute WP, IP is defined as WL minus WP, so it will be equal to 1. And at W shrinkage limit, this is the 1. So here what I would like to tell you, plasticity index is given by the formula WL minus WP, shrinkage index is WP minus WS, and toughness index is IP upon IF. Flow index is W1 minus W2 upon log N2 by N1, and liquidity index is W minus WP upon IP. And we also have IC plus IL is equal to 1. So here what I would like to tell you, there is another concept, my dear students. The concept here is sedimentation analysis. Now, my dear students, when you talk about sedimentation analysis, there was a famous question asked, sedimentation analysis is based on which law? Sedimentation analysis is based on Stokes law, my dear students. Sedimentation analysis is based on Stokes law, and remember, Stokes law is valid for the soil particles of size 0.2 micron to 0.2 mm. Okay. Okay. See, my dear students, if the sedimentation analysis is based on which law? Stokes law, and Stokes law is valid for 0.2 micron to 0.2 mm. Here, settling velocity is given by the formula G by 18 into S minus 1 into D square upon mu. Okay. And this formula can be simplified. Settling velocity can be written as 902 D square, where D will be substituted in mm, and you will get the velocity in mm per second. So here I should not write equal to, I should write approximately. So settling velocity can also be written as approximately 902 D square, where D should be substituted in mm, and the settling velocity will be calculated as mm per second. So here where Stokes law is valid for which, means if they ask you Stokes law is valid for which particle size, it is applicable for 0.2 micron to 0.2 mm. Now my dear students, I would like to tell you there are two methods actually. One is pipette method. For sedimentation analysis we have pipette method, and there is also called as the hydrometer method. But remember, pipette method is the standard method for determining the sedimentation. I'll tell you simply Amma, how this process will be considered. See students, you will take a solution here. If the soil particles will be at somewhere here, after some you will have a hydrometer or pipette, sorry, you will have a pipette like this, and the soil particles after time t, sir, initially the soil particles are at a here length, okay, at time t1. After time t2 they have settled. So what is the distance they have traveled is this distance, and what is the time? Velocity means what? Distance by difference between the time. So actually here they will ask you, what is this solution? This solution, you cannot do this experiment in a water or anything. This solution is known as dispersion solution. So which is the most standard method of sedimentation method is pipette method is the standard method. In dispersion solution we will have, this is also previous gate question my dear students, 7 grams of sodium carbonate we have. In dispersion solution we have 7 grams of sodium carbonate and 33 grams of sodium hexametaphosphate in 1 liter of water, distilled water, and 33 grams of sodium hexametaphosphate. They can write sodium hexametaphosphate. If it is not visible my dear students, please, I am writing again because the space is not. So please repeat, I am repeating again, sodium hexametaphosphate. So what is dispersion solution? Dispersion solution contains 7 grams of sodium carbonate and 33 grams of sodium hexametaphosphate in 1 liter of solution. In a hydrometer method, almost the method is same. Here the corrections are important, Amma. You have to write dispersion agent correction. When you add some dispersion agent, the correction will be negative, and meniscus correction is always positive, and the correction increases in, means the reading increases in downwards. Okay. So I quickly revise you what do you mean by index properties. Quickly remember here my dear students, what do you mean by index properties are? Index properties are useful for classifying and identifying the soil. Sieve analysis is useful for classification of coarse grain, and you can say sedimentation analysis and consistency limits for fine grain. If the particles of all sizes are present, then it is well graded soil and it is in S shape. If the particles are all of same size, uniformly graded, and it is steep in slope shape. If some particle sizes are missing, then it is called poorly graded soil or gap graded soil. When we talk about the coefficient of curvature, it gives you idea about the shape of the curve. It is given by the formula d square 30 upon d60 into d10, where d10 is the effective size, and the coefficient of uniformity is defined as d60 upon d10, where coefficient of uniformity gives you idea about the particle size and range. Next, coming to the Atterberg limits or consistency limits, means you have to remember the graph. These are the water constants at which soil passes from one state to the other state, from solid to semi-solid, semi-solid to plastic, plastic to liquid. Liquid limit means it has minimum water content, it has minimum shear resistance, that is known as liquid limit, and it is determined by Cascades apparatus. And flow index idea gives you about the shear strength, and flow curve, the slope of flow curve is known as flow index, and flow index is given by the formula W1 minus W2 upon log N2 upon N1. And remember, the next one we have is the plastic limit. You add some water into the soil and make it through rope of 3 mm diameter without breaking, then it is called as plastic limit. Shrinkage limit is, it is the minimum water content at which the soil has small shear resistance, it is the minimum water content at which the soil is fully saturated, or it is the maximum water content. Any further loss of moisture does not cause any change in volume. And plasticity in shrinkage ratio is the volume change expressed in terms of dry volume, and volumetric shrinkage is the volume change expressed in terms of dry volume. Shrinkage ratio is also defined as the mass specific gravity at dry state. And remember that graph my dear students, that is very important. And liquidity plasticity index is liquid limit minus plastic limit, shrinkage index is plastic limit minus shrinkage index, shrinkage limit, and toughness index is plasticity limit by flow curve, and liquidity index is W minus WP upon IP, and consistency index is W minus W upon IP. And this is all sedimentation analysis is based on Stokes law. Stokes law is valid for 0.2 micron to 0.2 mm. And if you see if the particle size is more than 0.2 mm, turbulent flow will happen. So we cannot apply the sedimentation analysis. Okay, and when we talk about the sedimentation analysis, we have two methods. One is hydrometer method and pipette method. Pipette method is the standard method, and here we are using dispersion solution, that is 7 grams of sodium carbonate and 33 grams of sodium hexametaphosphate in 1 liter of solution. When we talk about the corrections in hydrometer, meniscus correction is always positive and dispersion agent correction is negative, and the readings will increase when the meniscus moves downwards. Okay. Now coming to the next topic here we are going to discuss is the soil classification. The next topic I would like to discuss is what, my dear students? Soil classification. So how do you classify the soil? So here if we talk about a size 2 micron, and next we will talk about 75 micron, 0.425 mm. Okay, my dear students. Next we have is 2 mm, and next one we have is 4.75 mm. Next we have is 80 mm, and this is 300 mm. So everything is in mm, my dear students. These are all in mm. Okay, 80 mm, 300 mm. So my dear students, if you talk below, see, if more than 50%, is retained on 75 micron, then it is known as coarse grain. If more than 50% is passing on 75 micron, then it is known as fine grain. So here these things, what is coarse grain and fine grain, based on the particle size, you will be understanding. So here below 2 micron it is, you can say clay. 2 micron to 75 micron. Below 2 micron it is clay. Then it is silt. 75 micron to 0.52 mm it is fine sand. It is known as fine sand. 0.4252 to 2 mm it is known as medium sand. 2 mm to 4.7 mm it is known as coarse sand, and 4.75 mm to 8 mm it is known as gravel. More than 4.7 and more than 80 mm it is known as cobble, and more than 300 mm it is known as boulder. So based on the more than 300 mm, so based on the particle sizes, you have to remember here less than 2 micron clay, 2 micron to 75 micron it is silt, 75 micron to 0.425 mm fine sand, 0.425 to 2 mm it is medium sand, 2 mm to 4.75 mm coarse sand, more than 4.75 mm gravel, more than 80 mm cobble, and 300 mm boulder. So my dear students, if you are really liking this session, please share and please like and share this session. And as I told you, in civil engineering, we have an excellent team with Pratik Mishra and Ankit Dongrial. We are a very good team to deliver for you the best of our knowledge. And in mechanical also, we have extraordinary person Atul Negi, who has been taking mechanics yesterday. His session was well appreciated by all the students. And we have Mr. Prajna Tripathi for fluid mechanics, and he is an excellent professor in thermal engineering. And we also have Mr. Vijay Kumar, who is an extraordinary professor and he is a PhD holder, and he is Mr. Dr. Vijay Kumar sir, and he will be handling the production engineering. So stay tuned for this channel, and if you really like this session, my dear students, please like and share this session. It will help your friends. Now, my dear students, according to the American Association State Highways Transport Officials, or you can say Highway Research Board, or there is another corporation called Public Road Administration. So all these organizations are related to payment. What is their intention is, there is an organization called what, my dear students? There is an organization called AASHTO, American Association State Highways Transport Officials, or we have Highway Research Board, or Public Road Administration. So here when we talk about these three organizations, they want to identify the soil which is important for design of pavement. So their intention is, they classified the soil into 7 groups. Okay, they have classified the soil into 7 groups. That groups are taken as A1, A2, up to so on up to A7. So here what I would like to tell you is, now which group is best soil if you ask me, A1 or A2 or A7? Remember my dear students, smaller the group number, better is the soil for payment. So when I take A1 and A7, A1 is the best soil and A7 is the least soil. How do you say a soil is best for payment? If it is having more swelling, that soil is not best. If the soil is stable mineral, then it is the best soil for payment. So soil is classified into 7 groups. Black cotton soil will fall under A7 group. Suppose, my dear students, if you are getting A2 group as a student, I am also getting the group A2. So to identify the soil, which is the best soil, if you both are getting the same soil, means to identify the quality of the soil within the same group, then we are coming across a concept called group index. What do you mean by group index? Group index is used to indicate the quality of the soil within the same group. What do you mean by group index? Group index is used to indicate the quality of the soil within the same group. It depends upon percentage of soil passing through 75 micron, liquid limit and plastic limit. And you can remember the group index varies between 0 to 20. Here also the same concept. Smaller the group number, better is the soil for payment. So here American state highways transport officials or highway research board or public road, they all the three want to identify the soil which is useful for payment. They have classified the soil into 7 groups, A1, A2 up to A7. Smaller the group number, better is the soil for payment. If you want to identify the soil within the same group, which is the best soil, then you go with group index. And group index depends upon percentage of soil passing through 75 micron, liquid limit and plastic limit. And here remember students, group index varies between 0 to 20. Smaller the group index, better is the soil for payment. Now my dear students, we also have to talk about, one is the system called airfield classification system, or you also called as unified soil classification system. Airfield soil classification system or unified soil classification system is discovered by Kresgedes. And remember, this airfield or unified soil classification depends upon grain size distribution. Grain size distribution means particle size distribution or plasticity characteristics, that is liquid limit, plastic limit, shrinkage index and all, or it also depends upon compressibility. Based on these three, they have classified the soil into fine grained and coarse grained. Fine grained comes under clay and silt, and coarse grained will come under sand and gravel. And remember, Indian standard soil classification is derived from unified soil classification system. So if unified soil classification is depending on grain size, plasticity and compressibility, Indian soil classification will also depend upon the same properties. So here what I would like to tell you here is, gravel is represented by G, sand is represented by S, silt is represented by any one of the student, silt is represented by M, and if you see well graded soil is represented W, poorly graded is represented by P, and C, clay is represented by C. So I would like to tell you, around 18 groups are classified from the soil. If they tell you, my dear students, silty clay or silty clay gravel. One second, my dear students, I will give you best example. Okay. Here they can ask you, what is clayey gravel? What is clayey gravel? Clayey gravel indicates, it is denoted as GM. So my dear students, what is the one I would like to tell you is, as you move this side, so from this clayey gravel, what does it means is, you should move, as you move right side, the composition will increase. So gravel by weight, gravel composition will be more than clay composition. So here first of all, which is the highest composition? Gravel. So write that name G. After that it is clay. Sorry sir, it is not GM, it is GC. Sorry, no one has replied also. It should be written as GC. It should be written as what sir? GC. Sorry for that. Okay, what I would like to tell you is, GC is clayey gravel, and here what I would like to tell you, as you move towards the right side, gravel composition is more than clay composition. And one more thing, if they tell you well-graded sand, if they tell you it is well-graded sand, then it is remembered as SW. Well-graded sand is represented as SW. If they tell you poorly graded sand, then it is SP. So here, this is how the weight. So remember, whenever you are solving the problem, weight composition will be given first priority. And another important thing, my dear students, if liquid limit is less than or equal to 35, then we call it as low compressible. The soil is said to be low compressible when the liquid limit is between less than or equal to 35. When the liquid limit is between 35 to 50, we say it as intermediate compressible. What we will say? We will say that soil is intermediate compressible. And if the liquid limit is more than 50, we say the soil is highly compressible. So here, my dear students, you should remember low compressible is represented by L, intermediate compressible by I, and highly compressible by H. So why I am teaching this is, we have a very important chart. The chart is known as plasticity chart. Actually, when we talk about the plasticity chart, that is the main, means if you know that when it is low compressible, when it is intermediate compressible, you can understand that problem. Any problem, my dear student. Suppose if we consider this as an A line, we call this line as what? This we call it as A line, my dear students. So here we have some lines like this. One is liquid limit is 35 and here it is 50. So this a graph is drawn between liquid limit and plasticity index. So here, if you see here, when I draw values 4 and 7 at this, okay, or 1 second, student. Okay, 1 second. So here, if I take this value, whatever this value, this between 4 to 7, we call this as A line, my dear students. Please one. So when it is less than or equal to 30, above A line it can be written as clay, below A line it is written as silt. So here it can be written as MH or OH. Are you getting, my dear students? This is above A line, we represent as clay. Here it is MI or OI. Or here it is ML or OL. How I have written? Above A line, you have to written as clay. Below A line, you have to written as silt. Okay. Now here what I would like to tell you is, if the value of say 4 to 7, if the between plasticity index 4 to 7, we represent the soil as, when the plasticity index is between 4 to 7, we represent the soil is having dual nature. It has both the natures of clay as well as silt. But above A line, 35 to 50 means that I told you already. If it is 35 to 50 means it is intermediate. Below 35 means low compressible. Above 50 means high compressible, which I have showed you in the previous slide. And now, how do you classify? Actually, liquid limit will be, plasticity index for the A line is given by the formula 0.73 into liquid limit minus 20. Why this 20 came? Because this intercept will be at 20. Actually, IP will be equal to very important formula, that is 0.73 into liquid limit minus 20. And remember, whatever the value you have calculated at A, this will give you the location of IP using A line, or it will give you the location of A line, and you can calculate IP from the given data WL minus WP. From this data, whether it is above A line or below A line, you will decide, and from that you will decide whether it is a clay or a silt. Now, my dear students, if the liquid limit is less than 35, it is intermediate. Low compressible. 35 to 50, intermediate. More than 50, highly compressible. How do you differentiate silt and organic soil? Is there is a test, students. If the liquid limit after oven drying reduces by more than 25%, means if the liquid limit initially is 10%, after oven drying it has become 6 or 5, that means it has reduced more than 25%. Then in that case, we call that soil as organic soil. And remember, my dear students, when the IP value is between 4 to 7, you will tell that the soil is having dual nature. And above A line, you remember that soil is clay. Above A line, you remember. And below A line, it is taken as silt. And we have separate tests also to determine the organic soil. The order will be bad And you can say in case of organic soil, definitely that whatever the order or the color will be dark gray color. And if Cu is greater than 4, we can say well graded gravel. You can say well graded gravel. If Cu is greater than 6, you can say well graded sand. Or Cc is between 1 to 3, you can say it is well graded soil. Now for a soil to be well graded, Cu and Cc both conditions should satisfy. When IP value is between 4 to 7, then we say that the soil is a dual nature. And remember one more thing, my dear students, if the percentage of finer, is less than 5%, means if the percentage of soil passing through 75 micron is less than 5%, then you will tell that the soil is whether it is well graded or poorly graded. If it is more than 5%, then only you talk about clayey soil or silty soil. Means you talk about clayey gravel or silty gravel. I will quickly revise the soil classification topic, my dear students. Actually, soil classification based on the particle size, more than 50% is retained on 75 micron, then it is coarse grained. More than 50% passing, it is fine grained. American Association, State Highways, Transport Officials, Public Road Administration, Highway Research Board, they want to identify the soil which is suitable for pavement. They have classified the soil into 7 groups. Smaller the group number, better is the soil for pavement. And to identify the soil within the same group, they have come up with a concept called group index, and group index has given a numbers 0 to 20. Smaller the group index, better is the soil for pavement. And airfield classification or unified soil classification depends upon grain size distribution, plasticity characteristics, and compressibility. They have classified the soil into gravel, sand, well graded soil. They have classified almost into 18 groups. And what is Cl, Ci, Ch is low compressible clay, intermediate compressible clay, or highly compressible clay. Above A line we call it as clay, below A line it is called silt. And liquid limit 35 to 50, it is intermediate, more than 50 highly compressible. And when IP value is between 4 and 7, you will have dual nature of the soil. And remember one more important thing, my dear students, the weight composition will be given the highest priority. So stay tuned, students. I'll be back within 2 minutes. Okay. Please stay tuned. Okay. Don't miss this session. I'll be continuing. We have still more topics. Okay. Meanwhile, I'll be back in 2 minutes. Okay, welcome back, students. Welcome back. Welcome back. Very good answer, Vasu. Very good answer. Plasticity index is given by the formula 0.73 into WL minus 20. Very good answer. Now, see, students, we are moving into the. Am I audible, my dear students? Quickly respond. Yes, yes, yes. My dear student, is it okay? Please share to your friends, my dear students. Am I audible, my dear students? Click yes, yes. Okay, thank you. My dear students, see, we are next going to discuss about a topic called permeability. Now we are going to discuss about a topic called permeability. Now, what do you mean by permeability? I will tell you, please, my dear students, what do you mean by permeability? See here, permeability is simple topic, my dear students. If you have a tank, if I have a tank and it has a pipe and it has a valve, if you open the valve, the water will flow. If you close the valve, the water will not flow. So what do you mean by permeability? It is the property of the soil which allows the passage of flow through it. So what do you mean by permeability, my dear students? It is the property of the soil. Permeability is defined as the property of the soil which allows the, it is the property of the soil which allows the passage of flow through it. It is the property of the soil which allows the passage of flow through it is nothing but permeability. Now, my dear students, see here the velocity. See here, my dear students, the velocity is given by the formula I into K, where I is known as coefficient of, where I is known as hydraulic gradient. And if what do you mean by hydraulic gradient means loss of head per unit length. And remember, hydraulic gradient does not have any units. So this was also a previous GATE question, my dear students. What is the units of coefficient of permeability? If you see what is the units of coefficient of permeability units will be same as velocity units. So the coefficient of permeability can be written as mm per second, centimeter per second. So what is the velocity is given by the formula I into K, where I is the hydraulic gradient and K is the coefficient of permeability. And remember, my dear students, seepage velocity is given by the formula V upon N. So seepage velocity is given by the formula velocity upon porosity. Remember, my dear students, seepage velocity is given by the formula velocity upon porosity, and seepage velocity will be always greater than the actual velocity. Okay, seepage velocity will be always greater than the actual velocity because the porosity is always between 0 and 1. As the denominator is less than 0 to 1, seepage velocity is always greater than actual velocity. And you know, according to constant head test, discharge is given by the formula AIK, and where A is the area of cross section, K is the coefficient of permeability. And remember, constant head test is suitable, the test which is suitable for constant head test is suitable for coarse grained soils only. Now, there was another question, my dear students. Variable head test, or you can say variable head test, is given by the formula AL by AT into log E into H1 upon H2. This is the coefficient of permeability formula for using variable head test, and this test, variable head test, is applicable for which type of soils? This is applicable for fine grained soils. Okay, here in the name itself, in constant head test, head is kept constant, whereas here in coefficient of permeability, here AL by AT into log E into H1 by H2. Here there was a famous question asked in the variable head test, my dear student. If all the parameters are kept constant, if the head is falling from H1 to H2, and if the head is falling to H2 to H3, then the heads will be in the relation of, geometric progression. You know about arithmetic progression, you know about all those things, right? So it will be in geometric progression. So this is constant head test is given by the formula Q is equal to AAK. Variable head test is AL upon capital A into LE upon H1 by H2. What is small a is Small a is the area of the standard pipe. L and A are the area and length of the soil sample. T is the time taken for head falling from H1 to H2 is the time. And remember, my dear students, the coefficient of permeability is given by the formula D10 square into C into E cube by 1 plus E into gamma W upon mu. So this is another important property for coefficient of permeability. So if anyone asks you, permeability increases as effective size increases. As permeability and effective size are directly proportional, you can say rounded particle, or you can say what? So permeability increases with increase in size, effective size. And what is C? C is known as shape particles. And when I talk about the C, it is nothing but shape constant. Rounded particles are more permeable when compared to angular particles. Even though the equation shows, here see most of the people, here this is one of the important concept, Amma. Very good, Vasu. What I would like to tell you is, K is proportional to E cube by 1 plus E. From this, if you simplify it, K is proportional to E square. But this was proven wrong practically. Theoretically, it is correct. But practically, it was proven paradox or wrong. Why? Because void ratio more, the permeability will be less. Sorry, you can say that void ratio and permeability. Void ratio is less, permeability will be more. So here what I would like to tell you is, permeability does not, means it is actually depends upon the size of the void, not on the void ratio. Are you clear, my dear students? And permeability increases with increase in temperature. As you increase the temperature, there will be a decrease in the viscosity. So they can ask you, what are the factors affecting permeability? By using this equation, you can clearly explain. So permeability increases with increase in effective size, and permeability increases with the decrease in void ratio. Permeability increases with increase in temperature with a decrease in viscosity. And fully saturated soils are more permeable when compared to partially saturated soils. And remember, my dear students, when we talk about the horizontal permeability is given by the formula sigma I is equal to 1 Zi Ka upon sigma I is equal to 1 Zi Ka. But this is the formula for horizontal permeability, and in addition to this, in a horizontal permeabilities, the discharge will be summation. You should remember that the discharges will be equal to summation in a horizontal or parallel flow. And remember, the head loss will be the same in case of horizontal flow. But when we talk about the vertical permeability is given by the formula sigma I is equal to 1 Zi upon sigma I is equal to 1 to n Zi Ki. This is the formula for coefficient of vertical permeability. In case of coefficient of vertical permeability, discharge will be same. Head loss will be equal to sum of the head losses. So this will be equal to sum of the head losses. So these concepts will also help you in problem solving. And remember, my dear students, always remember, horizontal permeability is always greater than vertical permeability. There is a mathematical derivation for this. And apart from this, you can also write equivalent permeability. You can write that equivalent permeability can be written as Kh into root over Kv. Equivalent permeability is written as square root of Kh into Kv. And when two soils are transmitting from one medium to the other medium, if the soil is passing from one medium to the other medium, there will be a deviation here, theta 1 and theta 2. How the ratios of the permeabilities will vary is, the ratios of the permeability will be varying. K1 by K2 is equal to tan theta 1 upon tan theta 2. But whenever you are solving the gate questions, my dear students, along with these formulas, if you don't know what is horizontal flow, in a horizontal flow, actually the discharge will be same and the head loss will be summation. The same things when you talk about pipe connections and all. In a vertical flow or in perpendicular flow, discharge will be same. It is like series connection. Head loss will be summation. So next, this is what we are going to discuss about the permeability topic. Next, we are going to discuss about the effective stress diagram, effective stress. So this also I will tell you. See students, what do you mean by effective stress? Suppose if you consider a soil particle, there is a load going to apply in this soil sample. There will be some water particles also. Sorry, the voids are filled with water. Whatever the stress which is taken only by the soil particles, the stress taken by only by the soil particles. 1 second, students. Stress taken only by the soil particles is known as effective stress. And see here what I would like to tell you, my dear students, if we take the total stress will always be written as effective stress plus pore water pressure. So the stress taken only by the soil particles is known as effective stress, and the stress taken by water is known as pore water pressure, and pore water pressure is given by the formula gamma W into HW. This is what you known as pore water pressure. So this is known as gamma W is known as pore water pressure. So here when I talk about the effective stress will be taken as total stress minus pore water pressure. So effective stress will be taken as what, my dear students? Effective stress will be taken as total stress minus pore water pressure. What I would like to tell you is, whenever you are calculating the effective stress, it cannot be calculated directly. After knowing the total stress and pore water pressure only, the effective stress will be calculated. So I will show you a simple thing. In case of surcharge loading, whenever there is a case one, I will show you the diagrams. Whenever there is a surcharge loading, how will be the total stress and effective stress? The stress distribution will be in this way. So in case of surcharge loading, the stress will be uniform. The stress will be uniform, or you can write rectangle. Rectangle means same. Now, if I take a soil strata of a depth Z, and the soil is having a unit of soil depth Z, and gamma is the unit weight of the soil. In this case, the total stress will be taken as, here it varies hydrostatically or linearly, gamma Z, and minus pore water pressure is 0. So this will be equal to again gamma into Z. This will be also again into gamma into Z. Sorry for that. Okay. So here what is the statement I would like to tell you, my dear students? Effective stress will be equal to total stress when there is no water table. So please write down this point, my dear student. In case of no water table, effective stress and total stress will be same. That's what I would like to tell you. Next. Now, my dear students, if I take a soil strata with a water table, you can say this is water table, and soil is having a depth Z. And what is the condition of the soil? The condition of the soil is gamma sat. In this case, actually, see, my dear students, I'll tell you the shortcuts here. Here the total stress will be how much? The total stress will be equal to gamma sat into Z. And this is the total stress, and this is the pore water pressure. This will be equal to gamma W into Z. And you know this will be equal to gamma sat minus gamma W into Z. What do you mean by gamma sat minus gamma W? Gamma sat minus gamma W is nothing but gamma dash. That is actually, what is gamma dash? Is nothing but submerged unit weight. So, my dear students, whenever you are calculating effective stress, in case of water table, gamma sat will be replaced by what? In case of water table, whenever you are calculating effective stress, gamma sat will be replaced by gamma dash. So here why these widths are shown here more, somewhat less, because actually if you take the unit weights, gamma sat will be greater than gamma D. And remember, my dear students, gamma dash is usually the least unit weight. That is the reason we are showing the widths lesser. So here, remember, my dear students, the stress will be uniform in case of surcharge, and in case of water table, the effective stress will be calculated using the formula gamma dash. In case of other than if there is no water table, total stress and effective stress will be same. Next thing, my dear students, what I would like to tell you here is, if you consider a soil strata, if you consider a soil strata of depth Z. If you consider a soil strata of depth Z. Now, see students, what I would like to tell you is, and intermediate, this soil is having a unit weight gamma 1 and this soil is having a unit weight gamma 2. And if I consider this depth as Z1 and this depth as Z2, okay, there is no water table or anything, my dear students. In this case, the total stress diagram will be like this. Here you should understand that whenever there are two different weights, the slope here will vary. This you should understand, my dear student. Sir, effective stress can be written as total stress minus neutral stress. That is also correct. Actually, that is an important question, Amma. Actually, pore water pressure is also called neutral pressure because it does not have any engineering, it does not affect the engineering properties. So, actually, according to Pascal's law, pore water pressure is same in all directions. That is the reason it will not have any effect. That is the reason pore water pressure is also called as neutral pressure. So, I hope I have clarified 4 points, my dear students. In case of surcharge, the stress will be uniform. In case of whenever there is no water table, total stress and effective stress are same. In case of water table, gamma sat will be replaced by gamma dash. If there are unit weights are different, the slope will changes. And if there is capillarity action, my dear students, they can ask you another important thing. What is the due to capillarity action, how is the effective stress calculated is? Actually, effective stress will be calculated by the formula in the capillarity action using the gamma sat. There will be also question asked, what is the change in effective stress due to capillarity action? You can simply write that gamma sat minus gamma dash into whatever the height of the capillarity. That will give you the change of the change in effective stress due to the capillarity action. And one more thing, students, there are 3 types of water. One is capillarity water. Okay. Capillarity means what, my dear students? The rise or fall of a liquid is known as capillarity. Actually, capillarity height is given by the formula 4 sigma s force per unit length. What is centimeter? You see the distribution, you know what is means? Actually, the interconnected soil particles will act like a capillary tube through which there are 2 things. Another water called a structural water. What do you mean by structural water is, dear students, I'll quickly revise you the concept called compaction. The compaction, what do you see? Actually, in voids there are, one is air, another one is water. If you talk about the removal of air, then compaction is done by moving vibrating loads. When I talk about water, it is the removal of water from voids, then it is called consolidation. And water, when you do the removal of both air and water, then you say it is compressibility. When I talk about removal of both air and water, then you say it compaction. Sir, compaction is actually done to improve the, and you know the dry density G upon 1 WC is the water content and Proctor test of quantity 1 liter, because these kind of problems will also ask. And the soil is hammer weight is 21 centimeter. You have to remember, my dear student. Or the another one is nothing but what's Newton meter test. How this 593.01 came? It is nothing but you are dropping from a height, that is potential energy. So 25 weight is 2.5. So if you do the 2.6 is the weight of the hammer and 31 centimeter. Calculation, you will get a value of 593 point or the compacted Proctor test. But nowadays everyone is using modified Proctor test. But as the books we are studying about standard Proctor test, we are also following. And remember, as modified Proctor test is applicable, express here the soil is arranged in 5 layers. Here the soil is arranged in how many layers? 5 layers, 1 liter only. Here the volume is also 1 liter. About the hammer weight. As how much, my dear students? 45 centimeter. About the modified has 5 layers and each how many number of blows? 25 number of blows. Hammer weight is 4.9. This value will be equal to 2 students. What is the comparative effectiveness of modified Proctor test? The comparative effectiveness of modified Proctor test is 2703.88. There can be a question. The comparative effort 4 points, because you know this is 2703.88 and the standard Proctor test is not standard 4.55, 2703. Suppose if the soil particle sizes are more, if the 75 mm, if the percentage of soil retained on 4 is more than 20 percentile, if you see it is more than 20 percentile, then in this case, you have to increase 1 liter to 2.25 liters. From 1 liter to 2.25 liter volume has to be increased to 56 number of blows. The mold volume from 1 of blows. 1 second, students. Here, if you see the graph between this is and we have this is, so this is standard Proctor test. So here what I would like to tell you is this, if you draw water content on maximum dry density, and this is also the maximum dry density. So these points are called as OMC. We call it as optimum moisture. Good evening, very good evening, Shashikant. Okay, what do you mean by if you observe this, even at when compared to the standard gamma W into G upon 1 plus water content into G. Graph will be like this. If the size of the particles increases, see here, I'll tell you. If the size increases, this is for sand, it has low plastic clay, even at lesser water content. But when plasticity increases, dry density compaction is, as water content increases, dry density into OMC. You might have studied this point, my dear students. If you have drawn the graph between water content and dry density, there was a saying, my dear students, pure well-defined OMC. What does this well-defined means? The graph will be somewhere like this. You cannot plot at which point actually the dry density is maximum. So that is what is telling pure sands. Another formula called relative compaction. Relative compaction. What do you mean by relative compaction, my dear students? Density into the laboratory. So dry density in the field by maximum dry density into the laboratory is called relative compaction. We also have a concept called dry off optimum and wet off optimum. Remember, my dear students, dry off optimum means it has more swelling and more shear strength. Wet off optimum will have less swelling and less shear strength. Even though it is as it is having less shear strength, wet off optimum is used in case of core of earthen dam. So here, what do you mean by dry off optimum or wet off optimum? Here, you should understand this. Any doubts, my dear students? Vasu, Rakesh Verma, can you respond? Or Chandu, anyone? Okay, what do you mean by dry off optimum here is, here my dear students, dry off optimum is something like you have to add, the water content is lesser required, means you have to add water to reach the OMC. Means the amount of water content is less than the amount of water required for OMC is called dry off optimum. If the amount of water is more than the OMC, then it is called wet off optimum. And we have different equipments, my dear students. For cohesive soil, what is the equipment they can use is sheep foot roller. What is the equipment used for compaction for cohesive soil? It was asked in a multiple select question. Sheep foot roller is for cohesive soils, and for both cohesive as well as cohesionless soils. Pneumatic roller, it will be useful for cohesionless soils and cohesive. Pneumatic roller we have is pneumatic roller. Okay, so these are the things you have to remember, my dear students, in case of the equipments. And for sands, vibrators is the best method, and we also have tampers for trenches. So that's all for compaction, my dear students. What do you mean by compaction is the removal of air from the voids under shorter moving vibrating loads is called compaction. And why do you want to do compaction? To improve the engineering properties of the soil, reduce the increase the shear strength and reduces the permeability. And we have two types, standard Proctor test and modified Proctor test. And the modified Proctor test is 4.55 times the compact effectiveness of standard Proctor test. As water content increases, dry density increases, and here we have gamma D is equal to 1 minus Na into gamma Wg by 1 plus water content into G. Any doubts in this, my dear students? Any doubts? Can you quickly respond? Is there any doubts, my dear students? Okay. Now see, students, we also have to talk about the concept called stress distribution. We also have a concept called stress distribution. So how does actually in stress distribution, a soil is assumed to be homogeneous, semi-infinite, and homogeneous means same properties in same direction and all. So when I talk about stress distribution, the stress at a depth z. Suppose if you are having a soil with a depth z, that is a soil at stress depth z, and you are having a radial distance r, and if you want to find out the stress at a depth z, if you want to find the stress at a depth z, it is given by the formula q by z square. The stress at a depth is given by the formula q by z square into 3 by 2 pi into 1 upon 1 plus r by z whole square whole power 5 by 2. Whole power 5 by 2. So the stress at any point z is given by the formula q by z square. This was given by whom, my dear students? This formula is given by the formula Bosnick's theory. This theory is given by the formula Bosnick's theory. So whenever they have given, if they ask if the load is at here q, if at a radial distance r and a depth z, what is the stress distribution is q by z square into 3. Now at center, if they ask you at this point, the radial distance will be equal to 0. Similarly, remember Bosnick's theory is best suited for shallow foundations. Bosnick's theory is suited for what? Shallow foundations. Sorry. Bosnick's theory is suited for what? Shallow foundations. Clear, my dear students? Next. Remember, if there can be a question like this, the stress at depth z due to point load. If they ask you the stress at a due to line load, I should say, the stress due to line load. The stress due to line load. The stress due to line load is given by the formula 2q by pi z into 1 upon 1 plus x by z whole square. Okay, this is the stress due to line load. Okay. Is it clear, my dear students? Now, similarly, they can ask you for circular loading. Due to circular loading, what will be the formula? Vertical stress due to circular loading. If you consider this as a depth z and this as radius a, here the stress at a depth is given by the formula q into 1 minus cos cube theta, or it can be given as q into 1 minus of 1 plus a by z whole square whole power 3 by 2. Means only for this, for here only. So this is the vertical stress formula for which thing? This is the vertical stress formula for circular loading. Any doubts, my dear students? Next, if you see, the vertical stress formula is given by the formula Newmark's chart. Actually, Newmark's chart is based on Bosnick's theory, and he has given the formula, the vertical stress at a depth z is given by the formula I into n into q, where I is known as the influence coefficient, where I is equal to 1 upon number of radial lines into, where n is the number of radial lines, I is defined as 1 upon number of radial lines into number of concentric circles. Number of concentric circles. And here, when I talk here about n is known as the number of sectors. Where is n? N is known as number of sectors. And what is q is? Q is known as the intensity of loading. What is q, sir? Q is known as the intensity of loading. Okay. So here when I talk about the vertical stress, it is given by the formula vertical stress at a depth z is given by the formula I into n into q, where I is known as the influence coefficient, n is the number of sectors, and q is the intensity of loading. So this is what you have learned about the Newmark's chart. And another thing is, when they ask you Westergaard's theory, due to means the stress at a depth z due to Westergaard's theory is given by the formula q by z square into 1 by pi into 1 upon 1 plus 2 into r by z whole square whole power 3 by 2. This is the formula for using Westergaard's theory. The first initially I have described the formula due to Bosnick's theory, and this is okay. And one more thing, students, are you following, students? Okay, next, they can ask you the vertical stress distribution in a horizontal plane will be like this, and if they ask you what is the vertical stress distribution in a vertical plane, if they ask me, actually the maximum, if what will be the theta, if they ask you, theta will be equal to 39 degrees 50 minutes. The the stress at in vertical direction will be maximum, and R by Z value will be equal to, R by Z value will be equal to 0.817. The vertical stress will be maximum and R by Z value is equal to how much, students? It will be equal to 0.817. Now see, students, here I would like to add one more point, my dear student. See, whenever there can be a question here, they will give you at same load intensity. This will be some 2 meter into 4 meter. And they will ask you what is the vertical stress for 2 meter into 4 meter at a center. They might give you for 1 meter and 2 meter the corner value. They will give you the corner value some 100, and this will be 100, this will be 100, and this will be 100. What will be the vertical stress for this whole? They will give you for this portion at corner. If you want to add, you will add all those things. This is one of the things. And also in this case, there will be some equilateral triangle, there will be a load, it will be equally distributed on all the three parts, and you will be applying the, at one part, you will be, means if you consider the stress at this location, this directly at this location, it will be 0, but due to here and here, it will be at a distance R. So these things you have to be very clear, my dear students. Next, see, students, there is a concept called earth pressure, which is very important concept. There is a concept called earth pressure. Now see, students, this is an important topic, my dear students. If you are really interested for earth pressure, you can expect definitely a 2 marks question. Please like this session and share this session, students. In civil engineering at IMS GATE Academy, we have an extraordinary team. Myself, Sandeep Adari, with Air 192 rank with 10 years of experience. And we also have Mr. Pratik Mishra and Ankit Dongrial, who will be the best. Means we are all coordinating for the civil engineering team. And remember, my dear students, in mechanical also we have very good team like Mr. Vijay Kumar sir, and also we have Pragna Tripathi, we have Saurabh sir, and we have very good team of professors here associated with IMS GATE Academy. And we hope that these quick revisions will help you your valid time. So whenever you are interested, please share this session. That is the only help you can do, students, so that our IMS team will help the other students to our best. Now coming to the earth pressure, we have different types of earth pressure, my dear students. Actually, we have the one is active earth pressure, another one is at rest pressure, another one we have is the passive earth pressure. Okay, we have we have these things depending upon the wall moment. Actually, suppose if you take the wall moment here, if I take the wall moment here, so this is Kp, and this is K naught, and this is Ka. So from this diagram, you can simply say that passive pressure is greater than, at rest pressure is greater than Ka. I will explain you what is actually. If you say this is the wall moment, this is the wall moment, okay, and assume that this is retaining wall. Okay, if the retaining wall is stationary, my dear students, if the retaining wall is stationary, then it is known as active earth pressure. Extremely sorry. If the retaining wall is stationary, then we said it is the at rest pressure. If the wall movement is away from the backfill, then we say it is active earth pressure. When the wall movement is towards the backfill, then we say passive earth pressure. So here Kp into Ka is always written as 1. Okay, and you know Kp will be equal to 1 plus sin phi upon 1 minus sin phi. Remember either Ka or Kp, and remember Kp will be always greater than Ka. Okay, Kp is equal to 1 by, so Kp is equal to 1 plus sin theta by 1 minus sin theta. What will be Ka? 1 minus sin phi by 1 plus sin phi. So Ka will be equal to how much, students? Ka will be equal to 1 minus sin phi upon 1 plus sin phi. And what will be equal to K naught? K naught is nothing but the at rest pressure, and that will be equal to 1 minus sin phi. K naught will be equal to 1 minus sin phi. From this, so K naught, if you write here, K naught is equal to 1 minus sin phi. This also you have to remember. So you have to remember here, students, Ka is equal to what? Ka is equal to 1 minus sin phi by 1 plus sin phi. Kp is equal to 1 plus sin phi upon 1 minus sin phi. K naught is equal to 1 minus sin phi. Now, my dear students, this is very important, my dear students. I will tell you how to do that. Area of the pressure diagram. Always remember area. If you can remember this, it will help you while solving the problem. Remember, area of the pressure diagram is always equal to force, because pressure into area is equal to what? Force. So whenever you calculate the pressure diagram, to find out the force, just find out the area. So this is a very important concept. If you consider the active pressure is taken as Ka into sigma V, and passive pressure is given by the formula Kp into sigma V, and at rest pressure is taken as the formula P naught is equal to K naught into sigma V. Remember, all these are the formulas for cohesionless soils. If you consider these are the formulas for which soils, these are the formulas for which type of soils is cohesionless soils. Now, what actually is Ka? Actually, active pressure, passive pressure, all those are lateral earth pressures. Here, what is Ka? Coefficient of earth pressure means, coefficient of earth pressure is defined as, it is the ratio of horizontal stress by vertical stress. So what actually in coefficient of earth pressure it will happen is, it will convert this vertical stress to into a horizontal stress by multiplying with K. You might see like this, student, if you have a resultant here, how do you resolve the component F cos theta and F sin theta? How do you say that? F sin theta is vertical, means this sin theta is nothing but a coefficient to convert the resultant into vertical and horizontal. Cos theta will be for. Similarly, what is K is, it is dividing, means it is the ratio of horizontal stress to vertical stress. As you always know, the vertical stress, to convert into horizontal stress, we multiply with the coefficient of earth pressure, my dear student. So here, see students, what do you mean by active pressure for cohesive soils is given by the formula Ka into sigma V minus 2C root Ka. Ka into sigma V minus 2C root Ka is the active pressure for which type of soils? It is the formula for which type of soils, sir? This is the formula. This is the active pressure for which type of soils? This is the formula for cohesive soils. And similarly, if we consider passive pressure is given by the formula Kp into sigma V plus 2C root Kp, plus 2C root Kp. And this is the formula for active pressure and passive pressure in case of cohesive soils. And one more thing, my dear students, there is a concept called, very important concept. You can say very important. Tension crack depth. If anyone asks you tension crack depth, very important formula 2C by gamma root Ka. What is tension crack depth means? It is the depth at which active pressure is 0. The depth at which active pressure is 0 is known as tension crack depth. Similarly, critical height, this is called what, my dear students? Zc is known as tension crack depth. The depth at which active pressure is 0 is known as tension crack depth, and Zc is equal to 2C by gamma root Ka. And similarly, critical height is equal to what? 4C by gamma root Ka. This is known as what, sir? This is known as critical height. And here Hc will be taken as 2 into Zc. Hc will be taken as 2 into Zc, where critical height is defined as the height, or it is the depth at which active force is 0. The depth at which active force is 0 is known as critical height, and the depth at which active pressure is 0 is known as critical depth. Okay. Now, my dear students, see, whenever you are solving these kind of problems, first what I will tell you is, first step, whenever you are solving problems on earth pressure, first take the problem, first you have to calculate the coefficient of earth pressure. Okay. First you have to write the coefficient of, calculate the coefficient of earth pressure. The second step you have to do is calculate the vertical stress, not effective stress, sir. calculate the vertical stress. Please follow these steps, my dear student. After calculating the vertical stress, multiply, if I assume this as 1 and this as 2, multiply 1 and 2, multiply 1 and 2 to calculate the earth pressure. Means if it is coefficient of active pressure means you have to calculate Ka. If it is passive pressure means you have to calculate Kp. If it is at rest pressure means you have to calculate K0. Okay. From this you will calculate coefficient of earth pressure, calculate vertical stress and multiply. After this, area of the pressure diagram, as I told you, after this area of the pressure diagram will be equal to what, my dear students? Area of the pressure will be equal to force. And they can also ask you where this force act is. The force will act at the centroid. So remember these 5 steps. These first you have to find out the coefficient based on the earth pressure. Next, calculate the vertical stress. Multiply 1 and 2 to get the earth pressure, and area of the pressure diagram will give you force, and calculate the centroid, you will get the point of application of the force. Now see students, one more important thing I would like to tell you. Now see students, they will not give you active pressure, passive pressure or anything. If they tell you in the problem, no yielding of mass, that indicates that it is at rest, means there is no disturbance in the soil movement. If the yielding of soil mass, if the yielding of soil mass is due to stretching, or they can give you tension, if the yielding of soil mass is due to tension, then you have to calculate which pressure? Active earth pressure. Why? Because in some of the problems I have observed that they are not taking which earth pressure. So if the yielding of soil mass, if the yielding of soil mass is due to compression, then in case it is passive. Okay, based on these capacities also, you have to know whether it is an at rest pressure or active earth pressure or it is a passive earth pressure. Is it clear, my dear students? Is this clear? So no yielding of soil mass, it is an at rest pressure, or yielding of soil mass due to tension, then it is active earth pressure. Yielding of soil mass due to compression, then it is passive earth pressure. So this is a very, very important concept, my dear student. So here next thing what I would like to tell you here is, there is an important note whenever you are solving earth pressure diagrams. My dear students, most of the students will ask me this doubt, sir. You should be aware of this doubt. Suppose in the soil strata, if there is a water table, please write the total stress as, you have to write the total vertical stress as effective stress plus pore water pressure. You have to mention this as pore water and shaded. Why? In case of water table, so this is an important note, my dear student. In case of water table, total stress should be written as what? Total vertical stress should be written as effective stress plus pore water pressure. Why? Because the coefficient of the, what is the purpose of the coefficient of earth pressure is, the purpose of the coefficient of earth pressure is to convert the horizontal stress to vertical stress. To convert the horizontal stress into vertical stress, we are using coefficient. But whenever there is a water table, you have to write as effective stress into pore water pressure, because you will multiply the coefficient only for K for effective stress. You will not multiply with K because, or you will directly take it as 1, because according to the Pascal's law, pore water pressure is same in all directions. As the pore water pressure is same in all directions, you need not to resolve the vertical stress into horizontal stress. Am I clear? So this is one of the important thing, because in GATE, some of the people will be finding difficulty. So the important note here is, in case of water table, you need not to multiply the coefficient of earth pressure for pore water pressure. As the reason is, Pascal's law states that pore water is same in all directions. The purpose of the coefficient of earth pressure is, we are multiplying with the coefficient for the vertical stress to convert the vertical stress into horizontal stress. But according to Pascal's law, as it is same in all directions, the K will be taken as 1, or you need not to multiply with the coefficient of earth pressure. Is it clear, my dear students? So and one more thing, I'll quickly revise the topic on at rest pressure. Sorry, I'll quickly revise the topic on the earth pressures. 1 second, my dear student. If you want to have in one slide, students, see, I'll write here Kp is equal to 1 plus sin phi upon 1 minus sin phi. Ka is equal to 1 minus sin phi upon 1 plus sin phi. Anyone, if you are interested, you can take a screenshot. Okay, K naught is equal to 1 minus sin phi. Kp is equal Ka into Kp is equal to 1. Kp is greater than K naught greater than Ka. And remember, passive pressure is useful in design of sheet piles, active pressure in retaining walls, at rest pressure in bridge abutments. Now, for cohesionless soils, when I talk about the cohesionless soils, okay, active pressure is equal to Ka into sigma V. Passive pressure is equal to Kp into sigma V. Okay, and at rest pressure is equal to K naught into sigma V. When I talk for cohesive soils, when I talk for the cohesive soils here, active pressure is equal to Ka into sigma V minus 2C root Ka. Kp, passive pressure is equal to Kp into sigma V plus 2C root Kp. Sir, see here, if you have to mention that. And active force is equal to half Ka gamma h square minus 2C root Ka. Okay. Into H. 1 second, student. Into H. Here it is Ka. And remember, active force after formation minus before formation, active force before. They can ask you this question also. The difference in active force before and after formation is given by the formula 2C square by gamma. Very, very important shortcut, my dear student. The difference in active force before and after formation of tension crack is given by the, means after formation of tension crack, if you see the active force after formation of tension crack, before formation plus 2C square by gamma. The difference in active force before and after formation of tension crack is 2C square by gamma. Is it clear, my dear students? And tension crack depth Zc is equal to 2C by gamma root Ka. Okay. And critical height Hc is equal to, you can write it as 2 into Zc. This is also very important, my dear student. Tension crack depth is very important. Zc is equal to 2C by gamma root Ka. The difference in active forces before and after formation of tension crack is given by the formula 2C square by gamma. Very, very important. And it's a shortcut. Okay. The difference in active force before and after formation of tension crack is given as F 2C square by gamma. Next, my dear students, we will talk about the topic called consolidation. We will topic about a consolidation. So what exactly is consolidation is? It is actually, consolidation is a slow process, my dear student. Consolidation is a slow process. It is the removal of water from the voids. You can say consolidation is nothing but the removal of water from voids is nothing but consolidation. See, my dear students, when I talk about the consolidation, we have one is initial consolidation, primary consolidation, and also we have the secondary consolidation. So we have different types of consolidation. The removal of water just after the removal of air just after the application of load is called initial consolidation. The removal of water from voids is known as primary consolidation. And this is important, my dear students. Secondary consolidation occurs only after primary consolidation, and it is the removal of highly viscous water and plastic readjustment of soil particles. And secondary consolidation is proportional to logarithm of time. It is Terzaghi's theory is not applicable for secondary consolidation. And secondary consolidation occurs at constant effective stress. You remember, my dear students, secondary consolidation is proportional to logarithm of time, and secondary consolidation occurs at constant effective stress. He has explained the consolidation in a beautiful way. There is a theory called Terzaghi piston model. It was given as spring, and you have a load here and you have a pipe here. He has explained in a beautiful way. Here there is a valve, and here we have a water. So this case they have asked, this spring, whatever this thing is there, no, this spring is assumed as soil particles, and these are known as water, and this is the load which is having here, and this valve is assumed as permeability, and whatever the effective stress on water is pore water pressure. The stress on the spring is known as what, my dear students? The stress on the spring is known as effective stress. So whenever I talk about the consolidation, you have to know the coefficient of consolidation is given by the formula K upon mv into gamma w. And remember, my dear students, mv is known as coefficient of volume compressibility, that is equal to delta h by h, delta h by h into delta sigma dash, or it can be also written as delta v by v into delta sigma dash. And you know what is mv? mv is known as coefficient of compressibility. What is cv? cv is known as coefficient of consolidation. And if anyone asks you what is the coefficient of consolidation units, what is the unit, sir? Sir, K units will be meter per second square. This will be meter square per kilonewton, and this will be kilonewton per meter cube. If you solve this, if you see, the coefficient of consolidation units will be meter square per second. And here you can write mv is equal to what, my dear students? What is the mv? mv is known as coefficient of volume compressibility. What is mv, my dear students? mv is known as coefficient of volume compressibility. Similarly, my dear students, they can ask you what is coefficient of compressibility. Coefficient of compressibility is known as what? AV. Coefficient of compressibility is known as AV. It is the ratio of, it is the ratio of decrease in void ratio. It is the ratio of decrease in void ratio. It is the ratio of decrease in void ratio upon increase in effective stress. And the coefficient of units is meter square per kilonewton. And you know, you can write here. These are the important formulas, my dear students. You can write here. See here. Delta V or delta H by H. Another important formula is delta H by H can be written as delta E upon 1 plus E naught. This is another important formula. Okay. So from this here, see students, if I substitute here delta E by 1, you can also write mv is equal to AV upon 1 plus E naught. You can write mv is equal to AV upon 1 plus E naught. Is this clear, my dear students? Okay. This is a very important formula, my dear students. The settlement delta H is given by the formula delta H is equal to Cc into log of sigma final, that is sigma naught plus delta sigma dash upon sigma naught upon 1 plus E naught into H. Here there will be a big question mark. What will be the H? Because consolidation happens in clay only. Whenever you are taking the H here, H should be taken as thickness of clay only. Okay, or sigma naught plus delta sigma dash will be taken as the final effective stress. This will be taken as the final effective stress. And Cc is known as what, my dear students? Cc can be taken as coefficient of compression index. What do you mean by Cc, my dear students? Cc will be taken as coefficient of compression index. Cc is taken as coefficient of compression index. Actually, in soils, my dear students, there are two soils. One is undisturbed soil and another one is disturbed soil. In case of undisturbed soil, coefficient of compression index is given by the formula 0.009 into liquid limit minus 10 percentile, which is given by the Terzaghi for undisturbed soil, and Cc is equal to 0.07 into liquid limit minus 10 percentile. This is given by Skempton. This is for undisturbed soil, which is given by Terzaghi, okay, and this is for disturbed soil, which is given by Skempton. Is it clear, my dear students? Okay, so MV is coefficient of volume compressibility, delta H by delta sigma dash. AB, coefficient of compressibility, delta E by delta sigma. MV is equal to AB upon 1 plus E naught. Delta H by H is equal to delta E upon 1 plus E naught. Usually the stress will be calculated at the center of the clayey layer. Usually the effective stress will be calculated at the center of the clayey layer. And one more thing, my dear students, here we have a factor called time factor. We have a factor called time factor. Time factor is given by the formula TV is equal to CVT upon D square. What is CV here, my dear students? CV is nothing but the coefficient of consolidation. T is the time taken for consolidation. T is the time taken for consolidation. And here what is D, my dear students? In case of double drainage, D will be taken as H by 2. D will be taken as H by 2 in case of which condition? D will be taken as H by 2 in case of double drainage, and D will be equal to H in case of single drainage. And remember, my dear students, we have a concept called, this is also time factor TV is equal to CVT upon D square. You know U is nothing but degree of consolidation. What is U? U is nothing but degree of consolidation. So degree of consolidation is given by the formula settlement at a time upon ultimate settlement. What is degree of consolidation formula? Degree of consolidation is given by the formula settlement at a time upon ultimate settlement. If they ask you percentage, means for every formula you have to multiply with 100. So here, my dear students, time factor actually is a function of degree of consolidation. So here what I would like to tell you is, if degree of consolidation is less than or equal to 60 percentile, here time factor will be taken as pi by 4 into mu percentile by 100 whole square. Time factor will be taken as pi by 4 into mu percentile by 100 whole square. When this is the formula for when time factor. If, my dear students, time factor will be also given as 1.781 minus 0.933 into log 10 into 100 minus mu percentile when the degree of consolidation is less than or equal to, when the degree of consolidation is greater than a 60 percentile. So these are the time factor formulas on different conditions. So what is degree of consolidation? Based degree of consolidation can be taken as settlement at a time by ultimate settlement. Actually, my dear students, I want to summarize the entire consolidation formulas. You have to know coefficient of consolidation CV is equal to K upon MV into gamma W, where MV is the coefficient of volume compressibility. AV, what is called as coefficient of compressibility, delta E by students. AV is equal to what, my dear students? Delta E upon delta sigma dash. Coefficient of volume compressibility is given as delta V by delta sigma dash, or you can write delta H by H into delta sigma dash. What is H? Delta H is nothing but settlement. H is the thickness of the clayey layer. Now, my dear students, MV, volume compressibility, can be written as coefficient of compressibility upon 1 plus E naught, and coefficient of compression index is given by the formula. So coefficient of compression index is given by, what is the formula? You can write, my dear students, delta E is equal to delta E upon log of sigma final upon sigma initial, or you can write delta H by H is equal to delta E upon 1 plus E naught. From this, the settlement formula delta H is equal to H into Cc into 1 plus E naught into log of sigma final upon sigma initial. This is the formula for effective stress. And remember, my dear students, what I would like to tell you, other important formula is degree of consolidation is settlement at a time by ultimate settlement. Time factor TV is equal to CVT upon D square, where CV is the coefficient of consolidation, which I have written earlier, and time factor TV can be written as pi by 4 into mu percentile by 100 whole square if the degree of consolidation is less than or equal to 60. If the degree of consolidation is more than 60, it is given by the formula 1.781 minus 0.933 multiplied by log 10 into 100 minus mu percentile. This is the degree of TB factor. So my dear students, we have different formulas, and remember one more thing, we have recompression index, which is usually 1 by 5 to 1 by 10th of compression index. And we have OCR ratio also, my dear students. We have also OCR ratio, over consolidated ratio. That is the, you can say the stress, this is the maximum stress that a soil have been ever subjected to the present existing stress. What is over consolidation ratio is, it is the ratio of maximum stress that soil has been ever subjected to the present existing stress. If it is greater than 1, it is over consolidated. If it is equal to 1, normally consolidated. If it is less than 1, under consolidated. Under consolidation will be taken example of area of recent landfill. Okay. Next, we have the important topics like seepage. Okay, this is another important formula. When I talk about seepage, what do you mean by seepage? Here, usually seepage pressure is nothing but the pore water pressure, or you can say based on the direction, it can also be written as I, because I can be written as what, my dear students? Delta H by L. Here, H can be written as what? I into L, or I into Z into gamma W. Based on the direction of the flow, it can be given as positive or it can be negative. Okay, thank you, Ashwin, thank you. So here, what do you mean by seepage pressure? Seepage pressure is the pressure that builds in pore water. So seepage means it is the pressure that builds in pore water. So based on the direction of the flow, the seepage pressure can increase or decrease. Actually, my dear students, we have different conditions. Like first condition we have is quicksand condition. Sir, my dear students, most of the people do feel that quicksand is a type of sand. Actually, quicksand is not a type of sand. It is here the gradient, hydraulic gradient at quicksand condition is known as critical hydraulic gradient, and which is a very, very important formula. What is IC here? IC is known as critical hydraulic gradient. What is IC? IC is known as what, my dear students? IC is known as critical hydraulic gradient. So here what I would like to tell you, my dear students, if the upward seepage pressure becomes equal to the submerged unit weight, in that case the effective stress reduces to 0. In this case, the condition is said to be quicksand condition. So quicksand condition is also taken as boiling condition. Okay, but the gradient at quicksand can be taken as critical hydraulic gradient, and critical hydraulic gradient, very, very important formula, G minus 1 upon 1 plus E, or gamma dash by gamma W. And another important formula in seepage is for piping. Actually, piping means if seepage is taking place below hydraulic structures, if some seepage is taking place below a hydraulic structures. And one more thing, seepage always acts in the direction of the flow. How the flow is there, in that direction only seepage will be acting. As I told you, seepage pressure is given by the seepage velocity is given by the formula velocity upon porosity. This is also. Now see students, if seepage takes place below hydraulic structures, there exists a gradient which is greater than critical hydraulic gradient. In that condition, we talk it about piping. Actually, in piping, in the previous gate questions, I am seeing a question on factor of safety for piping. You can write it as factor of safety for piping is given by the formula. It is the ratio of IC upon I. Next, when I talk about the quantity of seepage, my dear students, when I talk about the quantity of seepage, actually quantity of seepage is given by the formula. Quantity of seepage is given by the formula K into H into NF by ND. The quantity of seepage is given by the formula KH into NF by ND, where NF by ND is known as the shape factor. Where NF by ND is known as shape factor. What is NF? Number of flow channels. What is ND? Number of potential lines. Here number of flow channels is given as number of streamlines minus 1. And here see students, actually if you consider a streamline and if you consider the equipotential line, The streamline means it is a line along which a water particle travels. The space between two adjacent streamlines is known as flow channel. In equipotential line means it is the line joining points of total head. Another important, my dear students, when we consider total head, you will take pressure head plus velocity head plus datum head, right? Actually, this is very important, my dear students. In soil, velocity head is neglected. So remember, in soil, students, total head and piezometric head will be same. Why velocity head is neglected means it is very small. That is the reason it is neglected, because a soil cannot move like a water. That is the one of the reason. So whenever you consider in soils, velocity, which head is neglected, they can ask you. Velocity head is neglected. Quantity of seepage is given by the formula Kh into Nf by Nd. And see, students, there is another formula. The loss of head is given by total head upon number of potential drop. This formula will also help you. Okay, the quantity of seepage is given by the formula what, my dear students? Kh into Nf by Nd. And two streamlines never meet each other. Streamlines and equipotential lines are orthogonal to each other. And you say that the quantity of seepage or the drop in head in each flow channel is almost same. Okay, so these are some of the important formulas in seepage. Okay, we have covered all the last topic we are going to discuss here is the shear strength. So in shear strength, see students, actually, first of all, when we talk about Coulomb, Coulomb has told that shear strength is a function of what? Initially, shear strength is a function of normal stress. But when Coulomb and Moore, they have sit together and they have told that shear strength is a function of effective stress. So this is the observation. So shear strength is a function of effective stress. When you draw a graph between shear strength and effective stress, this is how it looks for a C5 soil. And if the angle is phi, okay, this is the cohesion C. From the straight line equation y is equal to mx plus c, shear strength can be taken as C plus sigma dash tan phi. Okay, shear strength is given by the formula C plus sigma dash tan phi is the formula for which soil? A soil which is having both cohesion and friction. Now, in case of cohesionless soils, the graph will be C will be 0. So in that case, the graph will be like this. So here S will be equal to sigma dash. So or you can write S is equal to sigma dash tan phi. Or whenever you say phi is equal to 0, so cohesionless soils means gravel and sand are taken as cohesionless soil. When phi is equal to 0 means pure cohesive soil. In that case, the graph will be in this way. So in this case, this will be equal to, shear strength will be equal to cohesion. And remember, my dear students, a soil is said to be plastic equilibrium condition. A soil is said to be a plastic equilibrium condition if the soil particles are near to the failure plane. So here also we have a condition. Actually, this is the condition where you find some problems also. Sigma 1 is equal to sigma 3 tan square 45 plus 5 by 2 plus 2c tan 45 plus 5 by 2. My dear students, if the effective stress is given, please replace this, because they will give you two soil samples and they will ask you to find out the C and phi based on two unknowns, two equations. And you also have to know in unconfined compressive strength, sigma D, there is a concept called sigma D, where sigma D is known as the deviating stress. And remember, deviating stress is equal to sigma 1 minus sigma 3, where sigma 3 is known as confining pressure. These problems, when you are solving problems, you will get all these things, students. So what I would like to tell you is unconfined compressive strength is you can say in case of, so here what is sigma 1? Major stress, sigma 3 is the confining pressure, sigma T is known as deviating stress. So if they give you unconfined compressive strength, okay, the first and the foremost thing I would like to tell you, if the unconfined compressive strength is QU, if the unconfined compressive strength is QU, the cohesion will be taken as half of the unconfined compressive strength. And there is a concept called sensitivity also, my dear student. The sensitivity is defined as the ratio of unconfined compressive strength of undisturbed sample to the disturbed sample. Now, why do you want to study about the sensitivity? Is it indicates the why do you want to study about the sensitivity? If anyone asks, it indicates the weakening of the soil due to remolding. When you do remolding, the soil gets weakened. How much it has weakened, that can be detected, means that can be studied by sensitivity. So in unconfined compressive strength, C will be taken as QU by 2. So here you will have unconsolidated undrained test, which you call UU test. So no drainage is permitted during shear stress or consolidation. For short-term analysis, we will be using. For sudden drawdown cases, we use consolidated undrained test, and we use consolidated drain test for long-term analysis, which is direct shear test. Okay, and one more important thing I would like to tell you here is the vane shear test, when both ends takes parts in shearing, both pi d square by 2 into h by 2 plus d by 6. This is the formula when both ends takes part, means you will have top cylinder, both ends that will be take part in shearing. If only one part is taking in shear, what is T called? Torque actually. This is called pi d square by Cu h by plus d by 12. And similarly, my dear students, they can ask you what is delta U3. According to, they can give you B into delta sigma 3. 1 second, student. There is, okay, means here they can ask you according to the Skimpton pore water pressure parameters, what is the increase in pore water pressure due to increase in deviating stress. So we have values for B and A. So you have to remember those values also. You have the last concept, that is liquefaction. Liquefaction in the name itself. When a saturated sand is subjected to earthquake loading, the pore water pressure suddenly increases and the effective pressure reduces to 0. In this case, the soil behaves like a liquid, and that process is called liquefaction. First of all, I would like to thank each and every student who has attended this session. With this, I have covered all the soil mechanics topic. If you have enjoyed this session, really, you can share this session to all of your friends. In civil, we have an excellent team with me heading, and Pratik and also Ankit will be also joining. They are my colleagues, Pratik sir and also Ankit. And we have an extraordinary team in mechanical also, Mr. Dr. Vijay Kumar sir, Pragnya sir, and also Atul sir, and also we have Saurabh sir. So I hope these quick revision sessions will help you. And tomorrow, means on January 7th, I am coming live for the subject geomatics, for the subject RCC, that is reinforced cement concrete. I will try my best, and if you really like this session, the only thing you can give it to me is one like or a thumbs up, and share to the students where this session will help them. And thank you one and all the best for GATE 23. I hope I have reached your expectations what is in the quick revision of formulas. If you really like this session, please click the like button and share it to all of your friends. And as I told you, we are having a good team with IMS GATE Academy, and we are starting our new batches, and you can visit our website imsindia.com. There you can see our the perspectives, like what we provide, the exercise book, theory book, and the test series. And we are giving freely the zero fee program. You can visit our website. If you really have any doubts with the civil engineering thing, you can get in touch with our IMS website, where you can have the login. You can post your doubts so that we can come in contact. I hope this session will help you. Thank you one and all for giving me this opportunity to share my knowledge with you. And tomorrow, don't miss the session on RCC. Thank you. Have a nice day and good night, and all the best for GATE 23.